All right, guys, we're going to take a look at Unit 1, AKS 1A, use mathematically applicable situations algebraically and graphically to build and interpret arithmetic sequences recursively and explicitly as functions whose domain is a subset of integers. So we're going to take a look at recursive. This is blank because you're going to write your own notes. So we're going to write your own question here, and here you're going to ask, what's the question asking you to find? How will Desmos be useful? Your work, your answer, and then rate yourself. All right, so we're going to take a look at the recursive. So let's say that this is the question, and I'm going to do a couple of these just to make sure you're okay. So I won't write the first one, I'll just do them, and then we just make sure that you just write your notes down right here and how Desmos will be helpful for you. All right, so let's take a look at the first one. It's just really important to understand what an minus 1 means. Okay, that is going to be your key term. So actually we are going to take a couple of notes. Let's see, I think I'll just write it over here on this side. An minus 1 means the previous term. That's very, very important, okay? Previous term or the one before, okay? Previous term or the one before. So when you have the question that says an minus 1, this just means the previous term. So this is the previous term, and then what are you going to do to it? I'm going to add 2. So this sentence is saying, hey, to find whatever you're looking for, take the previous term and then add 2 to it. So we're going to start with what we have. So a sub 1, okay, again, let me go ahead and write these notes just in case you don't have it. What does a sub 1 mean? It means the first term. Okay, so it's the first one of your actual sequence. All right, so again, if my first term is 2, so I'm going to have term, right? The question is find my fifth one. So before I can find my fifth one, I got to find my second, my third, my fourth, and then my fifth. All right, so I start with my first one. Again, what does this say? The previous term. Do what to it? Add 2. So wherever you see this, the previous term, you're just always going to put parentheses. Then do what to it? Add 2. Oops, not plus. Add 2. Okay, so take the previous term, add 2. So to find my second term, I'm going to take the previous term, which is 2, and add 2. And that's going to give me my next term, which is 4. Now this is my term that I'm looking for. So again, to find the next one, what do? I take the previous term, which is now 4, and do what to it? Add 2. So it's going to give me 6. Okay, so now my new term is 6. I want to find the next one. Again, what does the formula say? Take the previous one, add 2. So my previous one is 6. So I'm going to put 6 in here. Add 2, it gives me 8, and so forth. And so again, in terms of terms, this is my first one, this is my second one, this is my third one, this is my fourth one, and it wants me to find my what? My fifth one. So I need to do it one more time. So how do I find the next one? Take the previous one, and then do what? Add 2. So my fifth term is going to be 10. All right, so again, the key thing about this whole thing is understand, what does this mean? The previous term. All right, where do I start? At a sub 1. All right, so let's go ahead and do another question. We're going to do a couple of these because you need to know what they are. This looks like the same thing. It just starts on a different one. So we're going to go ahead and skip that one. All right, so again, what does a sub n minus 1 mean? The previous term. So whenever you're putting this in the calculator, started on the second one, the previous term is always in parentheses. And then there's a 2 in front of the previous term, right? There's a 2 right there. What does it mean? 2 times the previous term. That's all that means. But if you just write it where you put parentheses where it says previous term, you're fine. All right, my first term is 6. So I start with 6. All right, comma. To find my second one, you take the previous one and put it in the parentheses. So 2 times 6 is 12. So my second term is 12. And I want to go till I find my fourth one. So to find the next one, what do? I take my previous term. So my previous term, that's this part right here in parentheses. I put it right there. It gives me my next one, which is 24. All right, so again, now I delete this. Now this is my new term, right? To find the next one, I take the previous one, which is now 24. And that's going to give me what? 48. So my first term, my second term, my third term, my fourth term is what I'm looking for, is 48. So once again, big thing to remember about this, that an minus 1 means the previous term. That's what you're looking for. All right, that's kind of similar. Let's just see if the question changes. Again, what does this mean? Take the previous term and then do what to it? Add 5. Okay, so you're going to start with 7, then add 5, and keep going. All right, let me do another one. Take the previous term, and then this time, what are you doing? Subtracting 4. All right, let me do another one. Take the previous term, and then do what to it? Add 1. Let me do another one. That's the same one. All right, what are you doing? The previous time times what? -4. So let me do one of these ones. They're all the same as long as you remember that you start on the second line. Where you see previous term, that should be in parentheses. So it should be -4 parentheses. So go ahead and type it, -4 parentheses. Then you start with the first one. So my first term is 4. How do I find my second term? I take the previous term and put it in the parentheses. So -4 times 4 is -16. It gives me the next one. All right, then how do I find the next one after that? I take the previous term, which is now this, and it helps me find the next one, which is now 64. And you're going to keep repeating this process until you get to which one? The fifth one. All right, so I'm on number 3 right now. So take the previous term, which is now 64. It gives me the next one, which is -256. All right, what's the previous term now? -256. In order to find the next one is 1024. All right, so I need 1, 2, 3, 4, 5. All right, so I'm on the fifth one. So this is the fifth one, 1024. Okay, and that's the process. So anytime you see the previous term, a sub n minus 1, you're putting it in parentheses, and then a sub 1 is the first one, the one you start with. Let's practice. All right, so we're going to take a look at AKS1A again to use mathematically applicable situations, algebraically and graphically, to build and interpret arithmetic sequences recursively and explicitly as functions whose domain is a subset of integers. Okay, so we talked about recursive sequence. Now we're going to talk about making a table and equation, give you a linear situation and also an arithmetic sequence. So I'm going to talk about both in here, and what you need to know is the only difference between a linear function, okay, and an arithmetic function is that a linear function starts at the y-intercept. Your y-intercept is your start, it's 0. Whereas arithmetic functions, they start at 1. They start at a1, and that's going to be the main difference that you need to do. So I'm going to show you both, that way you understand the difference between both of them and you're prepared for your test. So let's go ahead and start off with arithmetic. Okay, so we have this situation. We're at Elizabeth's house. It's 120 miles from City A. She plans to drive at a speed of 30 miles every hour. So per every hour. Write an arithmetic sequence for the first 3 hours. Okay, so writing a sequence is what's happening in the first 3 hours. Okay, so remember, the only difference with linear is it starts at 0, whereas arithmetic starts at 1. So if this was a linear situation, right, she would start at 120. That's at 0. She has not moved. Okay. And actually, we're going to do this as a table. So let me make a table real quick. All right. So she would start at 0 is 120. This will be a linear. But this is not a linear equation that we're being asked to do. It's an arithmetic sequence. And that will start at A1, my first term, which is going to be my first term, right? So my first term is what? 120 minus the 30 miles she's already driven, because she's driving towards a house that's 120 miles away. 30 miles in, she's 30 miles closer, so it's less than 120. So this is going to be 110. Okay, so again, the only difference between arithmetic sequences and linear functions is linear, we start right here, whereas arithmetic, we start right here. Okay, so if we're being asked to write an arithmetic sequence, I'm not going to look at the 0. All right, for the first 3 hours. So I need 3 hours. So that's hour number 1. Hour number 2, hour number 3. So she's going to lose 30 each time, right? Because she's driving 30 miles every hour. So 110 minus 30 is going to be 80. And then 80 minus 30 is going to be 50. So we're losing 30 every time. So the sequence for the first 3 hours, and this is again an arithmetic sequence. We're not starting at 0. We're starting at 1. The 3 sequence, right, an arithmetic sequence, it'll be 110, then 80, then 50. Okay, so that's a sequence. However, if I was trying to write a linear function, okay, then I would say, okay, y equals my slope, which again is 30 miles an hour, right? So 30 miles minus 30 miles an hour, and then we start at 120. Whereas 0, at 0 hours, my y-intercept is 120 away. Okay, so that's the difference between arithmetic sequence and linear functions. So in your assignment, you are going to practice the linear situation, but I like it in terms of a table. That way you can see if it was a linear, you start at 0. However, on the test, when it's a sequence, whatever your number would have been for 1 is where you started. So Matthew is given a box of assorted chocolates for his birthday. Each night, Matthew treated himself to some chocolates. Okay, so think about the situation. What's happening? Matthew starts off with a certain number, right? So when he starts, he has how many chocolates in the beginning? He has 30. He hasn't eaten any. Every day he's eating what? 3 chocolates. So what's happening to his total? It's going down by 3. So this will be day after 1 day is at 27. And this is going to check you every single time. Next day he eats 3 again. So it's going to be 24. Next day he eats 3 again. So it's going to be 21. So again, just be careful in terms of what you're writing. Or what the question is asking. So if it's asking for a linear function, we start at 0. If it's asking for arithmetic, we start at 1. So right in my equation, what is my slope? I'm eating 3 every day, so it's going down, so minus 3. And what do they ask me to use in terms of t? And what did I start with? Plus 30. There's my linear function. Okay, so once again, the difference between a linear function and arithmetic sequence is that the linear function starts at 0 at the y-intercept, whereas arithmetic function starts at 1, a1. Let's practice. All right, guys, we're going to take a look at AKS 1B. That's to graph, analyze the key characteristics of linear functions using formal notation, i.e. interval and set notation, relate key characteristics to real-world situation and model representations. So on this one, what we're going to do is write an equation given a linear situation. So what are some keywords that I need in that? Well, I need an equation given a linear. So I'm going to come into my formula sheet because I want to find linear equation. I'm going to look at all that I have available to me. So I have quadratic equations there. Here's linear equations. And which one do you recognize? Y equals mx plus b, slope intercept form. So I'm going to start off with y equals mx plus b. And please excuse my handwriting, it's going to be a little bit messy today. All right, y equals mx plus b. And what you want to do is write on the right-hand side of this paper where it says, what is the question asking for? That's what you're filling out. It's just I don't have the ability to snip both, and you can see both the question and the answer choice. So please write on the right-hand side where it says, what is the question asking you for? To write y equals mx plus b. Is Desmos useful for this? No, because there's nothing to put in the calculator. You're literally reading it and putting them in here. So at the end of the snowstorm, so I'm going to put my highlighter on. If you don't have the ability to do a highlighter, you can just underline. So in fact, I will underline so I can show it to you. At the end of a snowstorm, Indigo saw there was a lot of snow on the front lawn. The temperature increased and the snow began to melt. So think about the situation. There's snow and then it's melting, okay, at a steady rate. There's a depth of 16. Okay, so every time I get a number, I'm going to underline it because those are the numbers I need to put in M and in B. All right, 16 of snow on the lawn where the storm ended and it started melting at a rate of 2 inches. So there are my 2 numbers. There is my M and my B. And now the question is, which one is M and which one is B? So let's go through some definitions. Again, please remember you're writing on the right-hand side over here. What is B? B is my y-intercept, right? It's where it crosses the y-axis and also where it starts, where it begins. So whatever I'm going to write here, it's my starting point. It's where it begins. And then what is M? M is my slope. So again, you're writing your notes on the right-hand side. All right, slope is the number that keeps happening. So your y-intercept, where you start, only happens one time. You can only start the race one time. But how you're running, that changes. All right, so 16, is that my start or is that what it's changing by each time? Is it changing by 16 every time or is that what I start with? All right, so hopefully you've said that that is what I start with. And why is that? Because it says the depth of my snow was 16 inches. So that is what I start. So therefore, that means that 16 inches is my y-intercept. So I'm going to put 16. I'm going to write it down here. But again, remember you're writing it over there. I start with 16 of my depth, right? And then it's doing what? What is the snow doing? It's melting at this rate. So this is every per hour. So every hour, it melts 2 inches. Next hour, 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 melts 2 inches. Okay, you get the idea. All right, so it's melting 2 inches. That's the number that keeps happening. Now, here's my question. If it is melting, is it going up, positive, or going down, negative, right? Is it becoming more or less? Hopefully you're saying melting is less, so this should be negative. All right, so they're my two numbers, and I just need my x here and my y. However, you have to use what the question is giving you. So what is this question giving me? Write an equation for s in terms of t. And we keep talking about this, but I'm going to go ahead and say it. So s in terms of t. That means s is my y, t is my x. So s in terms of t. T as a function of s. So I'm going to keep saying those words because, again, this is that function notation, okay, that you need to be very familiar with. So this is capital S is equal to negative 2t because those are the letters they're using. All right, so please use what they are asking you. And that's it. So what you're going to do is go into your delta math. You're going to find the question that says write equation given linear situation, which is question number 2. You're going to answer those problems. And if you have any issues, you're going to come and see me. After you finish that, you're going to do 2b. Okay, so after you're able to write the equation, 2b says you're going to interpret, all right, what it means. What does the y-intercept mean? What does the slope mean? All right, we know that the y-intercept is where it starts, okay, where it begins, or in terms of this question, is I start off with a depth of 16 inches of snow. In terms of my slope, what does negative 2 mean in the context of this problem? That my snow is melting by 2 inches per hour. So I'm going to actually go and give you that B one. So that's going to be this next one. All right, so we're going to take a look at this one in context. So now they already give you a context, right? I know that this is the one that keeps happening, and I know that this is where I start. But in terms of my question, what do these numbers mean? So the question says the slope of the function is, what is my slope? Negative 9. All right, which reveals, what does it reveal? So first, let's figure out what's happening. All right, so when Nicole left the house this morning, her cell phone battery was partially charged. The charge remaining in Nicole's battery as a percentage can be modeled by this, where T is the number of hours since she left the house. So what is my slope? Okay, it's going down. My battery, so I didn't have it fully charged, but it's going down by 9%, because it says in percentage, every hour. Well, I'm sorry, where T is the number of hours. Okay, so it's going down by 9% every hour. So that's what I'm looking for. Change the battery when the charge, no, that's like my start, right? So if the question was what's the y-intercept, right? It's what I start with would be this 72, and that would be the charge of my battery. The rate, okay, so this sounds better. The rate that Nicole's phone gains charge per hour. Am I gaining charge? How does that make any sense? No, I'm losing charge. So it's not that one. The number of hours till Nicole's phone dies. Is this the number of hours till I die? No, I'm losing 9% every time. The percentage charge that Nicole's phone loses each hour, that's what I'm looking for. Okay, so as long as you remember, this is your slope, this is the rate of change, and keep in mind it could be positive or negative, going up or going down. And then this is my initial start, and you just see it in the context of the problem, then you're going to be fine. All right, so that's how you do 2A and 2B. It'll be combined in as one question. Let's practice. All right, so now we're going to look at graph and analyze key characteristics of linear functions, include using formal notation, interval, and set notation, relate key characteristics to the real-world situation that the model represents. So last week we looked at it as writing it from context. This week we're looking at how do I write it from a graph, and then can I interpret what those things on the graph mean. So let's start by writing this from a graph. Again, it's very simple to write an equation from a graph. I need the formula for my linear situation. So let's go find the formula. All right, so let's go ahead and find that formula. So again, if you should know it, but if you forget, this is where you're looking. So I'm looking for something with linear. Here's linear. 3 options right here. What's the one I recognize the most? The very first one. So we're going to start by writing the formula, which is y equals mx plus b. And again, you have the right side of the paper or the back of the paper where it says, you know, additional notes where you can write this. I'm just writing it on the question. All right, so that's what I needed from the formula. So let's go ahead and take this question. I just need to write it. All right, so let's talk about, well, what is my slope? It is a lot faster to do this with by hand. So I'm going to teach you both. I'm going to do calculator and both. All right, so I'll start off by hand. My slope is my rise. So if I start at this point and I'm trying to go to this point, I'm going to rise plus 1, and then I'm going to run negative 1. All right, and if I put that in the calculator, my rise, positive 1, oh, that wasn't positive 1, positive 1 divided by negative 1, you can see it'll give me negative 1. So my rise and run will be negative x, and then my b is where it crosses the y-axis, which is negative 1. Again, if that's been getting you wrong, that's not a problem. We're going to put it right in here. The only thing is that we have to make it a table so we can write the equation in here. So we're going to go ahead and put in some coordinates. So let's start with this coordinate right here. So this is 0, -1. And I need at least 2. So 0, -1. And then here, I'm going to put this one, which is 1, -2. So it always has to go x and then y. 1, -2. Once I have 2 points, that's all I need. And you can see it's kind of graphing what I have right here. I'm going to put in the equation, which is y equals mx plus b. And again, there's some problems here. There are 2 things I need to change. For one, the table I'm telling the calculator, give me the equation form, has x1 and y1. So I have to make sure that everywhere I see a y, I put 1. Everywhere I see an x, I put a 1. So it relates to the table. But there's still an error, and that is for some reason, Desmos does not like this equals sign. It prefers you to put this squiggly line, which can be found by finding A, B, C, and then on the very bottom squiggly line. As soon as that happens, you can see it comes up, and look at that. It's giving me my y-intercept, which is -1, and my slope, which is -1 as well. So I'm going to type this answer in. So it's y equals mx plus b is my original equation, where m is -1, according to what it says right here, and b is also -1. And you can see immediately what happens. Green overlaps blue, and therefore I know that I am correct. All right, so in the test, you'll have a second part of the question, which will be to interpret linear functions from an equation. So there's no delta math on being able to identify. You just have to be able to identify what these things are. So what did I find my y-intercept to be, right? So this is my y-intercept right here. My y-intercept was -1. What is my slope? So this is my slope right here. My slope was -1. What was my x-intercept? So for that, in case they give you a graph that's not there, once you put the line, you'll see it right there. It's -1, 0, -1, 0. And it depends on how they want you to write it, because honestly, even this x-intercept could be written as a coordinate, which would be x first, which is 0, and then y, which is -1. Okay, so if it's not in there, go ahead and type your equation here and then click on the x-axis. So this is not something you're practicing on Delta Math, but it will be a question that is required. On Delta Math, however, you are practicing how to write given the linear situation from last week, as well as given a, what do you call this? A graph. Okay, so write given a linear situation. So that's if it's given to you in context, and there's a video for that. And then interpret what it means. What does this mean in context? And what does this mean in context? There's a video for that. And today's new video was writing equations of lines from a graph. Let's practice. All right, so we're going to take a look at appropriate domain for real-world functions. For ease of reference, I've already typed this into Desmos and put the equation here, but actually I will go ahead and do it again. So let me just have it ready. So if they give you an equation without a graph, you're just going to type it into Desmos to see what it looks like so that you can answer whatever questions need to arise. All right, the only thing about real world problems, you have to think about whether it's factually true, whether it can happen in real life. So it says type it into Desmos, click settings, make it a table, define your x-axis and y-axis according to the question. So let's read it. An object is dropped off a building. So just imagine it starts somewhere and it's dropped off. So as I drop it off, it comes down until it hits the ground. Can it go below the ground? No, it cannot. And that's the real world portion of it. Your graph goes below the ground, but it cannot go below the ground. All right, so 144 represents the height of the object. Okay, so the y-axis is height, and the x-axis is, let's see, x seconds after it's dropped. So this is time. All right, it's very important that you label just so that you can think through it. So right now, can I have negative time? Absolutely not. So I cannot have any of this graph. This graph is not possible over here. All right, can I have negative height? Absolutely not. So I cannot have this portion here and this portion. So really what the question is asking, whether you want to read through all of this or not, is basically you just drop the ball and it goes to right there. That's it. That's the new question. So it's asking you, what's the domain from real world? Well, the domain's going to be from 0 to whatever this number is, and that number is 3. Now, do I include 0? Yes. All right, 0. And then do I include 3? Yes. So that's how you write domain in real world. But now I'm going to answer it in the way the question wants me to answer it and think about it. And that's what this is designed for. It's designed for you to think, so remember this one is your x value. Can I have negative x? No. So this answer would be, does not make sense. And that's what it's trying to get you to think about. It's just, going about it in a long way. All right, so evaluate f of -2. So I go to where x is -2, it's going to be 80. Okay, that means that 80 seconds, and put it right there, 80 seconds after the object dropped, the object was how many feet up? Oh, I'm sorry, it wasn't 80. I'm tripping. I didn't read that. Meaning that something seconds, so the time was what? -2 seconds. So meaning that -2 seconds, after the object was dropped, the object was 80 feet above the ground. And that doesn't make sense. -2 seconds, you can't do it. So that does not make sense. What about when you have 1.5? That's positive 1.5. So now it's checking, can I have 1.5 of a second? And I can. We'll see if it makes sense. So we are saying f of 1.5 is 108. All right, meaning that 1.5 seconds after the object was dropped, the object was 108 feet from the ground. Does that make sense? After 1.5 seconds, the object's 108. Sure, because I can have half a second. So this makes sense. Okay. All right, f of 4. So come right here. We'll change that number to a 4. -112. So -112, meaning that 4 seconds after the object was dropped, the object was -112 feet above the ground. Is that possible for me to be -112 feet off the ground when this object is dropped? No. So this does not make sense. So now, based on all these observations, here are some definitions for you. So sometimes they'll ask you to write domain in terms of, what you know, like this or like this, right? Close, because it's close, 0 to 3. So set an interval notation, but sometimes they'll ask you in terms of definitions. All right, so can the answer be all real numbers? And what does all real numbers mean? Every number you can possibly think of. No, because I already know that this density makes sense. It can have negative time and you can have negative height. So no, it's not all real numbers. Then you go on to your next definition. Can it be non-negative real numbers? That means everything you can think of that's positive. So let's think about it. Can I be everything on this side? No. Why? Because after 3, what happens here? I have negative height. So no, I cannot have that either. All right, so now let's keep going through my definitions. Real numbers in A less than or equal to X less than or equal to B. What does that mean? So real numbers within a constriction. That means everything you can think of between 2 points. That's what I need. It's everything I can think of between these 2 points. So what is that called? Real numbers between 2 points. Okay, and you just go through reading what it means in order to see what your answer could be for your domain. So I'll just go over the other definitions just in case you get one of those problems. An integer, what is an integer? Numbers with no decimal or fractional piece from a set of negative and positive numbers. That's what an integer is, including 0. What are whole numbers? Whole numbers are 0, 1, 2. What are positive integers? 1, 2, 3. Or integers between 2 points, like we had integers between 2 points right here. Now, the only reason, let me go ahead and cover that too. The only reason this is not an integer between 2 points is because this made sense. I had a decimal in there. And remember, if you're looking at an integer, you're just talking about the numbers 1, 2, 3, 4. So I couldn't pick that one between 2 points because it includes 1.5. And so that's why they break it down for you here so that you can make sure that you pick the right definition here. Let's practice. All right, guys, we're going to take a look at Unit 1, AKS 1D. Use function notation to build and evaluate linear functions for inputs and their domains. Interpret statements that use function notation expressing a table, equation, or graph in terms of context. We're going to take a look at a table. So this is table to linear function. Find the equation of the linear function represented by the table below in slope-intercept form. So because you don't have a table, it is because I want you to write your own notes based on the table that you have. So this is table linear equation level 3. So I'm going to use this table, and again, you're using yours. So as I'm doing my question, you're doing your question. So if this was my question, then I would go ahead and write in here that my question is -1, 3, 2, 9, 5, 15, and 8, 21. But this is not your question. So you're going to pull up your question in DeltaMath so that you can write notes on how to do it. All right, so that's what you're doing in your notes. So notes are really you writing down what your question is and then writing notes to yourself on how to do it, that particular question. All right, in addition to that, once you finish that, if you look on the other side, there'll be additional notes. Okay, so what is the question asking you to find? So when it says find the equation of the linear function, what is it asking you? What is this equation of linear? pull out your reference sheet and see what an equation of a linear function or equation is. So here's my reference sheet. I'm just gonna make it a little bigger, and I'm looking for linear equation, and boom, okay, I see right here, linear equations. These are the three forms. What is the form you're most familiar? It's y equals mx plus b. So when I look back at what is this question asking, you're going to fill this out yourself. I'm not going to do this on every single one, but what is the question asking you to find? It's asking me to find y equals mx plus b. All right, now that you know what it is, how will Desmos be helpful for you to do that? How do I use y equals mx plus b from a table to find Desmos? Well, the question gives me a table. So first I got to put the question into Desmos. How do I do that? I press the plus symbol. So I would tell it, all right, plus symbol. And again, write your own notes because these are mine, all right? This is what I understand. Plus symbol, then table. All right, then table. This is a quick reference sheet to use so that you can use it on your test. All right, input your numbers. So it's going to be -1, enter 2, enter 5, enter 8. Then here, 3, enter 9, enter 15, enter 21. And please double check your numbers to make sure you entered the right thing. All right, so plus symbol, then table, type it in. So again, type in question. Okay, these are notes to me. You write notes to you. Type in question, and then what do I do now? Now I got the table in here. I want it to give me this equation. So what do I tell the calculator to do? Well, I tell it, hey, give me this equation. So I'm going to type y equals mx plus b, and I'm going to go ahead and do that twice, and you'll see why in just a second. So I go ahead and do that twice. Now it's asking me, well, oh, this is different. This is exactly why you have to be in the testing calculator, because in a non-testing calculator, you can click this and actually pick it without you having to change it. So I'm going to switch over to a testing calculator. Do bear with me. I do apologize. So Desmos.com calculator, test, GA. All right, please, please, please make sure that you are in a testing calculator. So Desmos, graphing, state, test, GA, something like that. Make sure it's green. All right, perfect. I'm gonna put the table in. I'm gonna pause while I do that. Yep, and as you can see in the testing calculator, it doesn't have that option to where you don't have to type it in. So practice what it is that you're going to get on the test. So let's go ahead and type it in. I already know from my reference sheet that I'm typing in y equals mx plus b. All right, so I'm going to do it in twice, and you'll see why later. All right, so now it says, okay, there's an error. There's too many variables. Try defining M or B. All right, we know that there are two things that we need to change, right? Because the calculator doesn't like it. For one, I'm trying to tell it, give me the equation from this table. But here I define my variables as x1 and y1. Therefore, I have to make sure that every time I have a y, I have y1. Every time I have an x, I have x1. So that still doesn't fix my problem. As you can see, my y1s have disappeared. There's one more error, and that's going to be, it does not like this equal sign. It prefers you to have that squiggly line. So squiggly line is going to be shift and right underneath the escape button, or you can press ABC, and on the bottom row right here, there's the squiggly line. As soon as you do that, it appears. Please make sure, once again, that it lines up with all of your dots. So you can see your dots are green. If you highlight your circle right here, you can change the color to whatever color that you would like. So you can see everything is lined up. So this is the correct equation, which means my M is 2 and my B is 5. And I'm going to check that in the calculator. So I said my M, I'm going to replace that with a 2, and my B is 5. And if this is correct, red should line up with black, which it does, which lines up with blue. All right, so double check or triple check your answer in here. And then here, you're going to write down what you want, okay? So for me, I would say type in y1 squiggly line, mx1 plus b, and then look at what m is equal to and what b is equal to. Then you have y equals whatever it's equal to x, and then whatever the b part is. Okay, so again, these are just notes to you. Okay, so what is the question asking you to find? How is Desmos helpful to you? And this is the work on how you do it. Then here's your answer. So my answer was going to be for my question. And again, remember, you're doing yours on DeltaMath. My question checked and lined up is y equals 2x plus 5. And then you're going to rate yourself on this topic, okay? So where do you stand on this topic? For me, I think I'm great. So I'm going to go ahead and circle that one. I think this is one that I can definitely get on the test. I'm going to go ahead and circle it. And that's it. All right, so instead of looking at how to write a linear situation from a table like we did last week, we're going to be looking at how to interpret linear equations from context. So they give us a contextual problem right here. They're starting at noon. And what time is noon? Noon is 12 p.m. So starting at 12 p.m., Michael's observing the amount of snow on his lawn during a blizzard, where S represents how many inches of snow that was on his lawn. So this should have been an S, to be honest. I apologize for the typo. How many inches of snow is his lawn, and T represents the number of minutes past noon. So this is going to be T. So what is S as a function of time? Okay. What does this mean? So we know that this is my time, okay, and it says that T represents the number of minutes past noon. So my time starts at 12 p.m. and we're going to do 15.5 minutes past noon. Okay, so 15.5 after noon. Okay, 15.5 minutes after. So basically this is saying so what's 15.5 minutes after noon? That's going to be 12:15. This is interesting. 12:15 p.m. and 0.5 is what, 30 seconds, right? At 30 seconds, all right, at 12:15 p.m. and 30 seconds, there will be 30 inches of snow. Okay, so at 12 p.m. and 30 seconds at Michael's place, there'll be 30 inches of snow. I'm going to change this question a little bit and make it, instead of saying the number of minutes, let's say I said the number of hours. So let's call this B and let T represent hours past 12 p.m. past noon. Okay, so I'm going to answer two questions in one, just so in case this is what you're getting on your test. All right, so what is 15.5 hours, because now I've changed the question to hours, afternoon. All right, well, let's visualize the clock real quick, right? It starts at 12 right here. It goes to 3 there, 6 here, and 9 here. All right, this is 12 p.m. All right, if I go full round circle, how many hours have I gone? Well, hopefully, if you're starting right here and these numbers are going in sequential order, you'll see that those are 12 hours. So one full circle is 12 hours, right? But I'm trying to get 15.5 hours now that I've changed the question to hours. So I've done 12 hours. So if I subtract 12 hours from the 15.5, I'm going to be left with, I need to do 3.5 more hours. So now I'm back at 12, but it's no longer 12 p.m. What time is it? If I did 12 hours later from p.m., it'll be now 12 a.m., right? Then I'm going to do 3 hours after that. So this is going to be at 3 a.m. and 0.5 is 3:30. So at 3:30 a.m., this is what it's saying. At 3:30 a.m., okay, there's 30 inches of snow. Okay, so that's just interpreting. So there are two questions I'm asking you. The first one was in minutes. Now the next one is in hours. What does this represent? This is the time after 12 p.m. and this is how much snow there is at that time. So depending if the question is asking you in minutes or in hours, that's how you go about representing it. Let's go look at your Delta Math. All right, so it's a multiple choice question. So let's go ahead and handle that. Emily's math teacher finds there's roughly a linear relationship between the amount of time students spend on their homework and their weekly quiz scores. This relationship can be represented by this equation, where y represents the expected quiz score. So this one right here is the expected quiz score. X represents the hours spent. So X is how much time you study, and you'll get this score. What is the meaning of the X value when y is 85? So again, y is 85. That's the score I get, whereas X is the number of hours in order to get the 85. So I'm looking for some answer that talks about I spend X hours and I'll get 85. A student expected score if they spent 85 hours. No, this is not hours because Y is what? Y represents the expected quiz score. So that's not it. The number of hours a student should spend on their homework to expect a quiz of 85 on the quiz. That's exactly it. How many hours a student spent studying all year? Nope. A student expected quiz score if they spend no time on their homework? Absolutely not. So this is the answer. So these contextual problems, what you have to do is kind of read through them and then put yourself in that situation to understand what's happening before you answer the question. Let's practice. All right, so the next one we're going to look at is write a single inequality form context. Okay, so again, what are my keywords here? I'm writing an inequality. That means I don't want to see an equal sign. I want to see greater than or less than. All right, from context just means from the words. All right, so let me read my situation. So Avani and her children went into the grocery store. They're going to buy peaches and mangoes. Boom, P and M. Each peach costs 0.25. So anytime I have a number, I'm going to highlight it with my keyword. So a peach is 0.25. Each mango, so mango, costs $1.50. Avani has a total of $15. So I'm underlining or highlighting my keyword total as well to spend on the peaches or mangoes. And before we start, right, if I have 15 bucks to spend on peaches and mangoes, do I have to spend all of it? Okay, just keep that in mind. Write an inequality for what would represent the possible values of the number of peaches purchased P. So they tell me use P for peaches and the mangoes M. All right, so you just have to use their variables. So I can buy a peach for how much? 0.25. And again, I'm doing my work here, but you should be doing your work here. Okay, so actually, let me see if I can make it fit because I don't need the calculator in this one. All right, so over here, it says, what is the equation asking you to find? Write a single inequality. So you can just write that down, okay? So what is it asking you to find? Write a single inequality. Okay, how will decimals be useful? It won't. So NA means not applicable. All right, where's my work for it? So this is where you put in your work. I keep putting it here because I don't take a screenshot on both. But when I put it here, you'll remember you're going to put it right here. All right, so what's my work? So peach is 0.25. So 0.25. And what is the letter they asked me to use? P. Plus, okay, how much is a mango? $1.50. So $1.50. M. Now, I know that my total is going to be 15, but I don't have to spend $15. So for here, you need to actually put, whatever needs you need to put in order to help you remember. This means less than, okay, and again, I showed you this is small for less. Okay, so this is less. All right, this means greater than, and again, big, okay, for greater than, greater. That way you know what the symbols are. Now, the key word is what tells you what to use. So if I can have a total of $15, okay, I have a total of $15. Can I have 16 if all I have is a total of 15? No. So I am not using greater than. I'm definitely using less than. Now, do I have the option to spend exactly $15 on peaches and mangoes? Yes, because I have the money. I can go to the store and no one's going to arrest me, right? So I have the money. I have $15. So I can say I'm going to spend less than or equal to $15. Now, what I want you to do when you're practicing this one on Delta Math, so whatever your question is, I need you to write down these words. So my keyword is minimum. All right, so again, let me just go over a few just to kind of help you through it. If I have a minimum of I'm going to say $5, okay? If I have a minimum of $5, okay, can I have 6? So just think about it for a second. So in fact, pause the video and see if you can answer these with me. So I'm going to write the notes right here. Of course, it's going to be for different problems, but I'm going to write it right here so that we can keep it. So I'm not writing minimum, but you should. All right, so if I have a minimum of $5, can I have 6? Yes, because I can have $6, it's greater than. Okay. Can I have exactly $5? Yes, so then it's greater than or equal to. Can I have less than? Can I have $4? If I have a minimum of $5, can I have 4? No, so it would not be less than, it would be greater or equal to. All right, I'll do another one. New problem. All right, dimes and quarters. Now, on this one, you might get a little confused. There are numbers here. There are still 3 numbers. You just have dimes is equal to how many cents? So again, I'll write that on the side here. So how much is a dime? 10 cents. So you should have 10 cents, and I think the letter is D for dime, plus, and then how much is a quarter? 25 cents. So you write that as 0.25 Q, and then whatever the situation is, here is $2. All right, and again, let's do this inequality. No less than $2. Okay, I have no less than $2 in my pocket. So pause and think about it. I have no less than $2 in my pocket. No less. Can I have $1? No, because I just said I have no less than what? $2. So the minimum I must have is $2. All right. Can I have $3? Yes. Can I have $4? Yes. So it's numbers that are 2 and what? Greater. So this one is greater than or equal to 2. All right. So boom, greater than or equal to 2. All right. So I'm just going to do maybe just a couple more. Where's my keyword? Total, we've already done. Next. Minimum, we've already done. Total, we already did. At least, okay. I have at least, and I have at least $240 in my bank account. Okay, I have at least $240. Pause and think about it. I have at least $240. Okay, can I have 239? No, because I just said I have at least 240. That means 240 is the minimum I can have. So I can have 240. Can I have 241? Yes, because it says at least. So this one is greater or equal to. All right, that's all there is to it. Let me see if there's a part B to this question. All right, there is. So I'm going to go ahead and do both actually. So that one is writing, and then after that, how do I graph it? Now I'm going to graph the same one that I wrote. Okay, so I'm going to graph the same one that I wrote. So I'm going to put my original one. Okay, this one's a different question, but I'm going to put the original one in my calculator. So 0.25p plus 1.50p is less than or equal to 15. Oh, there's an error. Why is there an error, Miss Ainley? Because, hey, calculator, I only use X and Y. Okay, cool. I'll use X and Y and just remember to change it back to P and M in the equation. So there is my X and Y. So if I go to graph it, it says I have a point right here at 10. So I'm going to come on my graph and put a point right there on 10. Okay. I need to find another point. So I'm going to zoom out for a second so that you can see all of it. Remember, I'm looking for corners. To find corners, I zoom out until it's going up by 1. So 1, 2, 3. All right, so it's going up by 1. I'm going to start at the 10. All right, and you're looking for a corner. Okay, so try and find a corner with me. Is this a corner? No. Is that a corner? And what am I talking about? So you see this box right here? That's one box, and the corners are here, 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 and here. Top left, top right, bottom left. All right, is this a corner? Nope. That a corner? Nope. That a corner? Nope. That a corner? Nope. This a corner? Yes. So I can double check it by moving my cursor real close, and if it is correct, it's a corner, you'll see it become the coordinate. So this is the coordinate 6, 9. All right, so I'm going to go back to my paper. 6, 9 is a coordinate. Now be very careful when you're plotting this. Is this a dotted or closed line? It is closed or solid. So boom, solid line. And then where do I shade? Everything underneath it. Excuse my shading. All right, and that's it. That's how you're graphing linear inequalities. So you're just going to type it all into Desmos and find two coordinates, plot them, and then make it solid or dotted, and then shade. Let's practice. All right, so we've already covered this here in the previous question that I just did with this one. So I'm going to cover it again just to make sure you're okay. So this one is linear inequality system graphically. So linear inequality system graphically. So I go to that one. And all you're doing for this one is putting it in the calculator just like I did in the last problem. So I'm not doing that question. I'm going to do the one in your notes. So zooming in, I'm just going to type it in. So y is greater than or equal to 2x minus 8. And then my second one is going to be y is greater than negative 1 over 3. And again, please make sure that you're copying it exactly. So double check that this is exactly that. Once you're sure that it's fine, then you're good. So we have two inequalities. We're going to put them on this graph right here and then shade it. And right now it looks like a hot mess. So I'm going to press home for it to kind of zoom out. If that doesn't work, just zoom out and zoom in. All right, so I need to focus on numbers that are less than, and I'm just going to, I'm going to hide the second inequality, hide this so I can see. And then I'm going to zoom out till it's going up by 1, not by 2, 4, 6 or anything else, going up by 1. I'm going to check the intercepts because that's the fastest way to check. So I got 4 zeros. So I'm going to go ahead and transfer 4, 0 right here. All right, so you're going to put 40 right there. I'm going to go check to see if this is a y, and it is, so -8, but I don't have -8 on my graph, okay? So I can't use that one. So it looks like I can only stay above the x-axis, so I'm just going to go start at the x-axis and stay above. All right, so the numbers for the y right here faint, 1, 2, 3, 4, 5, 6. So even though I've kind of moved it, it doesn't matter, these numbers move with it. All right, so again, remember, this is one box right here. So you're looking at top left, top right, or bottom left. That's what you're looking for. So you tell me where you see a corner. Is this a corner? No. What about that one? Yes. Whenever you think you found a corner, you're just going to highlight it. Drag your mouse, carefully and slowly until if it becomes a full number, then you know you found a corner. So 5, 2 is a corner. So I'm going to transfer that up. So 5, 2, this is a corner. And so then draw that line and it's solid. Oh my gosh, my mouse is so bad. That was so bad. But you know what you're going to do. All right, so that's my first line. All right, now I'm going to do my second line. So I'm going to click this, hide that, unhide this. Click this to hide. All right, so again, I'm going to come to my intercepts because that's the fastest way to find it. So 0, 6. I'm going to use a pen. If I use the pencil now, I'm going to use a pen. All right, so I'm going to put a point there and then go see if it's on the, yep, I do have it on the x-intercept, but do I have 18? I don't. So that means I need to find it. Again, make sure I'm going up by 1 and I'm looking for a corner. Corner, no, right here. I think this is a corner. All right, so boom. 3, 5. So 3, 5. Now, the big thing about copying this over is please make sure you're copying it. That first one was a solid line, but what's this one? A dotted line. So when you're drawing this one, it has to be what? Dotted. Boom, 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 boom. Okay, that's my other one. Now, I am only, whenever you're drawing these solutions, you are not shading each one. You're shading just the overlap. So I'm going to press home so I can see it better. Where does the black line overlap with purple? Where does black overlap with purple? Where does black overlap with purple? Well, you can see here it's black but gray. Gray is only here. Purple's only here. Here is white. It's neither one. So it has to be right here. And if your colors happen to be the same, you can long click it and then you can change the color. So where does black overlap with, well, whatever color this is? What is it? Like a red? Red. All right, so again, here is red only, here is purple only, here is white, here is the overlap. So anything in here, stay away from what? Dotted lines. So you can this be a solution? No. Why? Because it's dotted. All right, but can this be a solution? Yes, this, and anything inside here is a solution. So when I come to go ahead and put my shading in them, only put in the overlap. So I'm only putting this part right here. And oh my gosh, my shading is so bad, but it's okay, you get the point. So anything in here, stay away from this dot. All right, so now that I have that, look at the kind of answer choices you're going to have. The 0.64 is a solution. Okay, well, I don't feel like reading this. I'm just going to type it in. I can type 64 if I don't want to look for it. So there's 64. Is this a solution? No. Why? Because it's on a dotted line. It must satisfy both inequalities. All right, so 64 is a solution for inequality 2, but not inequality 1. Okay, so I need to know which one was 2 and which one was 1. So 1 is the purple, 2 is the red. So is it a solution for inequality 2? So inequality is the red. Is it a solution for this dotted line? No. So it's not it. So we just have to read. All right, the 0.64, so it's the same point, is not a solution for this system of linear. Yes, and this might be select all, I don't know. So I'm just going to keep going. All right, so yes, it is. It's not a solution because of this dotted line. The 0.64 is only a solution for this system, is the only solution for this system. No, it's not a solution at all. The 0.64 is one of many solutions for this system. No, it's not a point at all. So the only answer it could be is B. All right, so very, very important. Again, remember for your solutions, the overlap, stay away from dotted lines. Let's practice. All right, so we're going to take a look at writing systems of linear inequalities. Now, because DeltaMath doesn't have the option for you to write, what we're going to do is we're going to practice with write system of equations. And remember, anytime you're doing equations, okay, what does that spell out? Almost an equal sign. So this one's going to be an equal sign, but the only difference is they're going to change it from equations to what? Inequalities. So we're going to practice both because delta math doesn't have the opportunity for you to do the linear ones as write the system. But we're going to practice both. So the first one we're going to do is write systems of equations from context. So please pull that up. So remember, this one should have equal signs. Okay. Now there are 3 different questions that you can get. You can get 6 numbers. All right. So let's first see how many we have. So I'm going to do this one right here. How many numbers do I have? So again, if you don't have the highlighter tool, what you're going to do is just simply underline it. All right, so for us, let's underline. Find my numbers rich quick. So apples, and then sorry, $1.75, and I'll go and underline apples as well because I need my keyword. Raspberries, that's $1.25. I need my keyword. Audrey made at most. I need that as well. At most, my keyword and the number. From selling a minimum, again, I need the keyword and the number. Of raspberries, write a system of equations. This is a mistake. It should say inequalities that could represent the number of pounds, blah, blah, blah. All right, define the variables that you use to write the system. So you're the one who is defining the variable. And remember, you're determining the number of pounds of apples sold and the number of pounds of raspberries sold. So that's what you are doing when you determine your variable. All right, so again, we are going to use this to write also a system of linear inequalities. The only difference with the equal sign and the non-equal sign is the keyword here, like at most, okay, a minimum. That's what takes it away from an equation to an inequality. So we are going to practice both. All right, so again, we'll do this question real fast. So system of linear inequalities, word problems with this. So we got 1, 2, 3, 4 numbers. Okay, so we have 4 numbers. All right, so if you have 6 numbers, you're just going to write it in order, 2 sentences, and you're good. If you have 4 numbers, you're going to have 2 options. It'll be either 4 numbers, which one is going to be in a word problem, or 4 numbers where you can just see the 4 numbers. So here you can see the 4 numbers. It's just regular straight up 4 numbers, not with a twist. If you do need those ones, please go rewatch the video of me going through it in detail. So right now I'm just doing a quick review. All right, so let's go ahead and get started. We need to define our variables. Are we good with saying, because it doesn't say, are we good with saying A for apple? So A equals apple. And again, please excuse my really bad handwriting. And what else is here? R for raspberries. All right, and remember, it's the number of pounds. So when you're choosing what you're defining, you're using the number of pounds of apples sold and the number of pounds of raspberries sold. All right, so let's go ahead and put my numbers. So this is $1.75. Once again, remember, you're doing your work over here on the side. So in 7a, what is the equation asking you to find? You're finding 2 inequalities. Okay, so write 2 inequalities. Now, I can't really write very well with my mouse, so that's going to be on you to write what I'm saying. All right, so 2 inequalities. Will Desmos be useful? No, because this is just reading and writing, so not applicable for Desmos. Here is my work. An apple is $1.75. So 175A plus, and again, we're looking for the things that look alike, right? And what is this? What are my 3 things? I totally forgot to say it. Money, 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 money. Money, 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 money. So in this situation, it's money, right? But you're looking for 3 things that are in every single number. And usually it'll be right after or right before. So you're looking, maybe it'll say, I don't know, 1.75. I don't know. I can't even think of an example right now. Kgs. And then this will be 1.25 kgs. And then this will be 124.50 kgs. All right. So again, you're putting the 3 numbers together. All right. They go together. So this is 1.7a plus 1.25. Oh, let me change that to a pencil. 1.25. And again, please excuse my handwriting. Just listen to what I'm saying. R. All right. And it goes with 124.50. All right, now we're going to leave the inequality for just a second. Then the other number I have just 80 pounds of apples and raspberries. I have both, right? So what do I have? I have apples plus raspberries, and those are going to be what? 80 pounds. All right, so I think we can all set it up. I think the issue comes into the words and what they mean. So let's look at the keyword with 124 at most. So this is at most. So I'm going to give you smaller numbers to think about. I have at most, I have $5. At most, I have $4. At most, at a maximum, at the most, I have $5. Do I have 6? No. So at most, I have $5. Can I have 5? Yes. Can I have 4? Yes, because at most I have what? $5. Can I have 3? Absolutely. Can I have 2? Yep, I can have 1. At most I have $5. So what is that? So again, remember you needed to write this in a previous question. This means less because that's small. This one is big, so that's greater than, and go ahead and write those down if you don't know them. So right here I have 5 or less than. And look, if you look at the direction of the arrow, it looks like which one? This one right here. So less than or equal to my $5, or in other words, $124.50. All right. This other keyword with the 80 is a minimum. So where is it? Minimum. So I have a minimum of $5. And again, I just use $5 for a smaller number. A minimum. Can I have $4? No, because I just said I have a minimum of $5. So I can have $5. Can I have 6? Yes. Can I have 7? Yes. Can I have 8? Yes. A minimum of $5. So anything above $5 and up. And if you look at that arrow. It's big right here. So this should be going like this, but I can also have $5, and that's how I determine my inequalities. So please make sure if you're not comfortable with this, you are definitely practicing it. Okay, so the only difference between equations, like I said, is this will be equal sign, and then when you do system of inequalities, it'll be an inequality. So my test is going to be on inequalities. Now, when you get on delta math, there is one little difference. So let me go ahead and make sure I get a question from that. This one is the same. This is just what we practice with the equal sign. Why is it equal? Because there's equation. But when you go do the next one, system of inequalities, in order to answer the question, you have to write the inequality, but really it's asking, determine the maximum number of peaches. So you're going to use the inequalities to give you whatever it is that you're using. So I'm going to do the work over here on one of these questions real quick. So Madeline and the children went to the grocery store where they sell apples for $1. Oh, look, it's apples again. So this is $1.75. All right, so $1.75, and I'm defining A for apples. Okay, and peaches for $1. So $1 for my peaches. Okay, money. So it's gonna be $20. All right, and I'll come back and deal with that because it has to be put in there. All right, so in fact, let me do it now. Madeline has $20 to spend and must buy no less than, okay, so that's extra. But she has $20 to spend. So can she spend 21? No. Can she spend 20? Can she spend 20? Yes. So she can't spend 21. Can she spend 19? Yes. So it's going this way. And look at my arrow like that. So I'm going to put my arrow like this. And I'm going to include the 20 because she can spend 20. All right, now listen to what she says. All right, you must buy no less than 14 apples and peaches together. So what does that mean? That means apples plus peaches, all right, 14. And what's the key word? No less, no less. Okay, so let's think about it. Can I buy a total of 14? Yes. Can I buy 13? No, because it says no less than what? 14. So I can buy 14, but I can't buy 13. Can I buy 15? Yes. Can I buy 16? Yes. So look at my arrow. Okay, so it looks like this. And can I buy 14? Yes. So I include it like that. So those are my two inequalities. You have to write the inequalities in order to solve the problem. So now it's telling you, actually I am going to use Desmos for this one. We're going to go ahead and type it in Desmos. And again, remember in Desmos, I cannot use A, so I'm going to use X. And Y is less than 20. And then we're going to use A plus P is greater than equal to 14. All right. Now, oh, I said A and P after I said you can't use it. Okay, you cannot use A and P, Miss Ainley. Come on, get it together. All right, how do I know where my solutions are? It's where the colors intersect. So where does blue overlap with green? Where does blue overlap with green? Right here. So anything in here, okay, and on this line, even this, on this line, why? Because they're solid. Stay away from what? Dotted lines. So these are my solutions. So now that you have your solutions, you can go back to your question. And my question says what? If Madeline decided to buy 3 apples, so which one was first? Let's see, when you put it in, A was apples, right? So X is apples. So if X is 3, so I'm going to go to 1, 2, 3. All right. How many peaches can she buy? All right. She can buy anything from here. So 3 goes with this one, this one, this one, this one, this one, and you can buy half an apple, so not that one. So anything here, but it says determine the maximum. So that means I have to get the what? The biggest number of peaches. So again, I go to 3. And what's the maximum number of peaches? Can I get higher than, so let me zoom in actually. Let me zoom in a little bit. So you see 1, 2, 3, here's 3. All right, here I will get 3 apples, 11 peaches. Here I will get 3 apples, 12 peaches. Here I will get 3 apples, 13 peaches. Here I will get 3 apples, 14 peaches. Here I will get 3 apples, but I can't have 14 point whatever peaches. So what is the maximum peach I can have? Right here, 3 and 14. So you have to be able to write your, what do you call this? Your inequalities before you can actually solve the problem. So you write your inequalities and look at your solutions and then go ahead and answer the question. Let's practice. All right, guys, we're going to take a look at AKS 4A, rewriting algebraic and numeric expressions of variable and radicals. In other words, can you simplify, add, subtract, and multiply radicals limited to square roots and cube roots? So we're going to specifically look at how to add and subtract radical expression, express these in simplest form. So here's a delta math. Here's an example, and I want to make sure that I do cover an easy one before I go to the one where you have to simplify. All right, so we're going to look at this, and remember, we've talked about this before. If I had x, oops, I am on the wrong thing. If I had x minus 6x, right, what would you do? You'd combine just the coefficients, right? So that means 1 minus 6, which would get negative 5x. It's the same thing with radicals, only instead of the x, or in place of the x, now I have radical 5 minus 6 radical 5. Again, as long as the radicals, or the radicand, right, the number inside the radical, are exactly the same, then it's apples with apples, oranges with oranges. So this is the exact same thing as this one above. And again, I'm writing notes here, but you really should be writing notes here. Okay, what is the question asking you to do? How will Desmos be useful? Here's your work, here's your answer, rate yourself. Okay, so again, this work should be on this side. All right, so I want to make sure I cover the easy ones. If it's already in simplest form, in other words, if the radicals are the same, I can go ahead and subtract that. If they're not, I may have to simplify to check if they're the same before I can do it. All right, so let's do another question. So this one is negative 5 negative 5 radical 5. Okay, so if the radicals are already the same, just go ahead and pretend it's an x and combine it like you normally would. And you can even put that in the calculator. So you can put what is 1 minus 6, and it'll tell you it's negative 5, and then just put the radicand. Okay. All right. So now let's get to one where you have to simplify like this, right? Are my radicals the same? No, they are not. So because they are not the same, and again, let's go ahead and write our question here. All right. And you don't have to do this question. You can write down any question that you like. It's just up to you to find the questions that you need. Okay. So what is the question asking you to do? It's asking you to find the sum, okay, which can only happen if radical is the same. Okay, are they the same? No. So again, I got to do it. How is Desmos going to be useful? Check, answer as you go. Okay, that's how it's useful. But, you know, specifically, you have to write down how it's going to help you, or what you need to put in Desmos in order for it to help you. So I'm going to go ahead and copy the question in. So boom, my answer is 112.001. And as long as the answer stays like this, then I am good. Ooh, this is not even right, y'all. You see this? Miss Emily tripping. So we're going to take this part out. Yeah, we're going to take this part out real quick. And it should be like that. So please make sure, again, I keep saying this, make sure that you copy it exactly. So that radical should not go over the whole thing. It should be looking just like that. So my answer is 115.12. And as long as it stays like this as I'm doing it correctly. So I'm going to start with this one right here. Let's see, can I break down 150? So I'm going to copy this whole thing onto a new line because it's the one I'm going to mess with, right? So first I'm going to mess with this 150. So we'll start off with 150. Oh, that should be on a new line. So I'm going to start off with 150. How can I break down 150? And again, you can check the lowest numbers to the highest numbers. So I can help the people who may not know how to do this right now. I'm going to start off with my lowest numbers. So I'm going to check divide by 2. Did that work? Yes. So what that is saying is I can replace 2 times 75 with 150. And I'm just going to prove that to you. And it's the only time I'm going to prove it to you because after this, I'm just going to do it. All right. So 2 times 75 is 150 because 2 times 75 is 150. 150 divided by 2 is 75. You can go either way. So I'm going to replace this with this. So I'm going to take that and put it in here. And if I did that correctly, it didn't change. So it does not change. It still matches. Now I'm going to go to my new number. So I already broke 2 down. That's as low as it can be. Now I'm going to do 75. So I'm going to try 75. It gives me a decimal, so that doesn't work with 2. Again, you should just be checking prime numbers. 3 works. So again, how do I replace 75? 3 times 25. So I come right here and I go 3 times 25. Do I get my 115? Yes. So I did this correctly. And you're going to keep doing this the entire time that you're doing it. So now I have 3 is the lowest it can be. Now I have 25. So I'm going to come right here and I'm going to make it 25. I'm going to check 3. 3 didn't work. Okay. Check 2. 2 didn't work. And again, if it's a decimal, it's not working. Check 4. 4 doesn't work. Check 5. Yes, it works. 5 times 5. So I can replace 25 with 5 times 5. And as soon as I do that, you see it still matches? Yes. Is this the lowest it can be? Absolutely. Okay. So now I'm going to move on to, before I do books, I'm going to break everything down. So I'm going to check 24. So I'm going to try and break down 24. So 5 doesn't work. Check 2. Yes, it does. So what does that mean? 2 times 12 replaces 24. So 2 times 12. Do I still have my 115? Absolutely. So now what do I have left? 12. So now we're going to replace 24 with 12. All right, 2 works. 2 times 6 works. So we're going to come here and we're going to replace that with 2 times 6. Checking my answer the whole time. Is it still okay? Yes, it is. I'm going to make this a little bit longer. I guess I can't. Let's make it this way so I can keep seeing. So now I'm on 6. Let's see if I can break down 6. So 6 divided by 2. Yes, that works. So 6 gets replaced with 2 times 3. All right, so again, I'm still good. And then now I have 3. 3 cannot break down anymore. So now I am ready. Once I have prime factorized it or broken the numbers down, now I'm ready to take books out. Well, how many cards make a book? All right, so we all know that square root, all right, doesn't have the cube right here. So it's 2 cards make a book. So I can see a book of what? 5. How many cards make 1 book? 2. So 2 of these cards will make 1 book outside. Okay, any more books in there? No. What about here? 2 of these cards, delete those, will make how many books outside? 1 book. And of course, it's giving me an error because it has this multiplication. So I'm just going to go ahead and subtract that. And again, if I'm doing this correctly, it's matching up. So I just check it every single time. Now I have 2 times 3 left. I can't make any other books. So what is 2 times 3? And again, if you don't know, you're just going to put it in the calculator, is 6. So I'm going to replace this with 6. This is also 2 times 3, which is also 6. And again, I'm still matching. So far, I am good. Out here, I have 9 times 5. And again, if you don't know your multiplication facts, you just go put it in the calculator. That's going to give me 45. Again, I replace that. Do I change? No, I'm still good. Now, what do you guys notice? It's the exact same question as the one before, right? It's like having 45 apples plus 2 apples. So just think of it that way. What is 45 apples plus 2 apples? It is 47 what? Apples. So now I'm going to replace this with 47. And what am I calling an apple? Radical 6. Boom. I am good. So this has been simplified to 47 radical 6. Hit submit, and you should be good to go. All right, so again, you're writing down your answers. Now, all the work that you've had on Desmos, on the Desmos calculator right here, you should have copied it down here just so that you can see. Again, this is you writing your notes for yourself. So you don't have to have used my question, but I do want to see the question that you did as well as how you simplified it. If you simplified it in the calculator, I want you to come ahead and show me what you did in the calculator here when I pick it up. All right, let's practice. All right, so we're going to take a look at AKS4B. Again, it's very similar. The only difference is that we need to explain that the sum or product of rational numbers is rational. The sum or product of a rational and an irrational number is irrational. And the product of a non-zero rational number and an irrational number is irrational. All right, so we're going to go to sum and product of rational numbers. Again, whichever question you're putting down is fine, but please remember to show yourself how to do this. So what is the question asking you to find? All right, so whether it's sum, product, how is Desmos going to be useful, the work, your answer, and then rate yourself. Okay, so I do want something written here. You're going to pick one of your questions. So as I do my question, you're going to pause and do yours in the exact same manner or fashion. All right, so let's go ahead and get started. So I don't even need to write it down here because I'm just going to do it in the calculator straight up. So here's the question, find the product. So I have already done a sum and adding and subtracting. So now I'm actually going to do a product, but you could get the sum in this question as well. It doesn't really matter. All right, so the product is, and again, I go ahead and type in my question because I am going to use the calculator to keep track of whether my question is right or wrong. All right, so first we're going to go ahead and type it in here at verbatim. All right, and I might just do a couple of questions. All right, so this is my answer. I want to make sure this is what I get. If you noticed, okay, when I was typing this in, did you see that this is already 20? Okay, so even when I put this back, all right, what we're saying is when I take this one, I can replace this whole thing with 20 because the calculator told me that. Okay, so I'm going to go ahead and do that because why not? Okay, it was right there. 134.16, 134.16. Okay, however, I am going to show you a different one. I will do this one, then I'll do another one. So this one I'll do too. All right, when you are multiplying, okay, so let's talk about the difference between if I had 2x plus 3x, right? What is that going to give me equal to? 5x. You just add or subtract the coefficients, just the numbers, and you leave the variable alone. But what if I had 2x times 3x? Well, you multiply, because it's multiplication, the coefficients, so it's going to be 6x. However, you also multiply the variable, so it's going to be 6x squared. Now, you do need to remember that. So that would be a good note for you to write over here, the difference between adding and subtracting versus multiplying. So multiplying is not just the numbers outside or my books, it's also my cards, okay? So everything gets multiplied. So in other words, what I'm saying, books go together. So 20 times 3, those get multiplied together. And again, if you don't know multiplication facts, you can put it right in the calculator. That's going to be 60. So multiply my books together, and you see it didn't change. Multiply my cards together. This one already simplified, so there are no cards to multiply. So this was it. Can I simplify 5 anymore? No, I can't. So this is it. This is all there is to this question. So I will do another one again. Now that I've gotten this answer, it's 134.1, blah, 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 blah. Let's talk about rational and irrational. This is irrational. Why? Because it cannot be written as a ratio of 2 integers, and its decimal expansion does not terminate or repeat. Look at it. Does it terminate or repeat? Now, keep in mind, this keeps going. Decimal's like, I'm just tired of writing it. All right, so if you see more than 1 to like 6 digits or whatever, it keeps going. And you can see there's no pattern to it, so then it is irrational. All right, like I said, I am going to do a different problem, one that doesn't simplify, so let me find one. This is sum, and again, I want to focus on product. Okay, this one will work. All right, so let's do this question. All right, so again, I'm going to type it in. You are making sure you're writing your notes right here. I know what I'm doing, so I don't need to write it down, but you do, okay, because you're going to use it. 3 radical 5. So find the product, okay? So what does product mean? It means to multiply, and again, be careful that you're not putting it in the wrong spot. All right, so it's multiplied by 3 radical 20. All right, so what did I say about taking the product? Okay, do the radicands have to be the same? No. Taking the products, okay, means that you multiply the coefficients or the books, and then you multiply the cards. So let's go ahead and just start with that, okay? So I'm going to do that first, and then I'm going to break it down. So what is 3 times 3? Well, if you don't know, we're going to put it right in here. All right, that's going to give me 9. So that's the coefficients, okay, the numbers outside. Now I'm going to multiply this. 5 times 20. Again, if you don't know what that is, you're just going to put it right in. All right, it should be 100. So inside the radical, I have 100, okay? Now, honestly, I didn't need to multiply it to 100. I could have just left it as 5 times 20. And the reason is because I'm going to have to break this down anyway, okay? So I'm going to break 100 down, and I already know it breaks down to 5 times 20, right? So I could have just left it as 5 times 20 because I know I have to break it down. You get what I'm saying? If not, it's okay, just break the 100, okay? So if I just confused you, I'm going to go back, and I'm just going to break the 100. They're both 90. Actually, why am I still doing this problem? What does it say it is? It's 90. So the answer is 90. It's not a decimal, it's a 90. So what is this? This is rational. Why is it rational? Because it can be written as a ratio of 2 integers. It's an integer, isn't it? And the decimal expansion does terminate or repeat. It terminates. This you can think of 90 as 90.0 or repeating 0, 0, 0, 0, 0, 0, repeating zeros, okay? But I'm still going to keep going because I don't want to find another example, okay? So I'm going to keep going to show you. So we're going to break down this 100. How do I break down 100? I already know it breaks down by 5. So when I check 5, it's 5 times 20. So I can replace this with 5 times 20, and that's still the 90. Okay, now I'm going to break down 20. Okay, so I come right here, break down 20. It breaks down in 5 times 4. So I'm going to come here and replace it with 5 times 4. All right, break down 4. So I'm going to come here, break down 4. That doesn't work, so we're going to start at the beginning. 2 Yes, that works. 2 times 2. So I'm going to break this down. 2 times 2. And again, the whole time I'm just making sure it matches. So it's still my 90. All right. How many cards make a book? Because there's nothing here, it's immediately 2 cards make a book. I see 2 cards of what? 5. 2 cards will make how many books outside? 1. 2 cards make 1 book. And again, just delete that little multiplication. You see, I'm still okay. I'm still doing it all right. 2 cards make what? 1 book. 1 book of 2. So I put a 2 outside. Now, there's an error because there's nothing left in my hand. If there's nothing left in my hand, I can put my hands down. And you see it still works, right? And then what is 9 times 5 times 2? 90. There's no cards left in my book. All right, so again, when you are multiplying radicals, they don't have to be the same radicand. In other words, the cards in your hand don't have to look exactly the same. But when you're adding and subtracting, if this is a 5, this also needs to be a 5. Okay, let's practice. All right, so this is 5.C, create and solve quadratic equations in one variable, explain the solution, solve by inspection, taking square roots, factoring, completing the square, and applying the quadratic formula. All right, so today's question is right here, find the solutions to this. So we're going to go ahead and type it in. I have shown you how to do it by hand, but at this point, I'm just going to show you how to use your calculator as well. So you just go ahead and type in the question, boom. All right, so I'm going to zoom out so I can find the graph, and it looks like no matter, I'm going to hide this real quick, no matter how far I zoom out, there is no graph, okay? So these are my previous notes. We talked about if it doesn't cross the x-axis, it has 0 solutions. If it only touches it 1 time, it has 1 solution. If it crosses 2 times, it has 2 solutions. So your options are 0, 1, or 2. Now, 9 times out of 10, I've put in some new notes for you right here. If a graph doesn't appear, you're going to take everything to the left and delete the equal sign. All right, so let's go ahead and do that. So the graph did not appear. I'm going to hit home again. It did not appear. Take everything to the left and delete the equal sign. So I mean, this needs to go to the left. So right now I have positive 2x. How do I get rid of positive 2x? I subtract 2x, but I have to do it to where? Both sides. So I'm going to subtract 2x from that side and subtract 2x from that side. Now, what is 2x minus 2x? 0. So that's why that disappears. And then so it says take everything to the left and delete the equal sign. Delete the equal sign. All right, so now it says there should be a graph, and boom, there it is. All right, so my question to you is, how many solutions does this graph have? Is it 0 solutions, doesn't touch the x-axis? 1 solution touches 1 time. 2 solution touches twice. This is the x-axis right here, so this has no solutions. So remember, there are cases where there's no solution. If that is the case, you're going to write no solution. So what is the solutions, or the roots, or the zeros, or the x-intercept? In this case, there is no solutions. So just remember, if your graph does not show up, it could be possible that's a no solution graph. And to get that, you need to take everything that's on the right to the left and delete the equal sign. Let's practice. All right, so we're going to take a look at IOA, AKS 6C. That's to graph and to analyze key characteristics of quadratic functions using formal notation, i.e. interval and set notation. Relate key characteristics to the real-world situation the model represents. We're going to focus specifically on average axis of symmetry, or AOS. That's the one we're going to look at. So we're going to go to Parabola Features. Okay, and we're only going to look at axis of symmetry. Now, the thing I do want to point out is this. Whether they give you a graph or an equation, if they gave you an equation, all you would need to do is put into Desmos. So let's just say this was the equation really quickly. All right, as soon as you put it into a Desmos, you can see the graph, okay? But today, what I'm going to focus on is just strictly from a graph. But if they give you an equation, you put it into Desmos and you can see the graph. All right, so from the graph, okay, what is the axis of symmetry? So remember, axis of symmetry comes from vertex notation, and it is the line that splits it in half. So what you're going to do is, no matter what your question is, so this one is my question, you're going to kind of rough sketch it. So I can see I have my vertex at 5, 1. So 5, 1 right there is my vertex, and then my x-intercepts are 4 and 6, and I just need a rough sketch. So something like that. Okay, my axis of symmetry, so this is my vertex, right? Let me just do different colors. So this is my vertex right here. These are my x-intercepts, right? So that you can know the different notation. And the question is, what is axis of symmetry? Well, axis of symmetry splits the graph exactly in half, symmetric, and makes the graph symmetric. And it always goes through the vertex. Now, at this line, and it is a line, therefore it must be an equation. At that line, x is always equal to what number? So I'm going to zoom in here and zoom in here so that you can see. At this line, x must always be equal to 5, right here. X must always be equal to 5. And you can see that no matter whatever y value I pick, so let's pick 3, x is equal to 5. Let's pick y is negative 5, x is equal to 5. X is always equal to 5, and that's why we say x equals 5. If you do not put that x equals, you are going to get the question wrong, okay? Because it is not a point, it is a whole line. So you have to put the equation. This means no matter what y is, x is always equal to 5. So once again, you should be practicing as I'm doing my questions so that you're not wasting any kind of time. And then on your notes, you want to go ahead and notate what it is you need to notate. So for question 11, if you come to it, it says additional note. What's the question asking you to find? So it's asking you to find what? The line of symmetry. So you just need to know symmetry. What it's asking you to find. How is Desmos going to be useful? So again, I'm not going to write all this down because this is part that you're supposed to write down. How is Desmos useful? It's going to be useful if you're given an equation, not a graph, and you can't see it. So if it's given an equation, you're going to type it into Desmos. Here's the work. Here's the answer. Rate yourself on this topic. That is all that there is to question 11. Let's practice. I did forget to mention in the previous video, compare features of tables and graphs. Type the equation into Desmos to make it a graph is what I showed you. However, I didn't show you that that's in your DeltaMath practice where it says compare features of tables and graphs. So you can get y-intercepts, you can compare those, you can compare x-intercepts, you can compare maximum or minimums. It's just a matter of typing it in and comparing. All right, so now we're going to take a look at the last question. Now, here's the thing with the last question. This last question, graph and analyze key characteristics of quadratic function using formal notation. In other words, interval or set notation, relate key characteristics to the real-world situation model it represents. In order to do this question, you have to know end behavior, axis of symmetry, and vertex, actually really just the vertex, and max and minimum, and increase and decreasing, because it's a select all, therefore you must know all. All right, so with that being said, I'm going to quickly go over each one, and each one is here individually for you to practice. So I'm going to begin in order of what I see. So end behavior first, and again, the question is empty, so you're going to put it in. So it says here that, you know, anytime you have some kind of equation, just type it into Desmos. Okay, so this looks crazy, all right, but it's fine because I'm just going to do what? I'm going to type it into Desmos. And remember, this is just practice. You're not going to get one that looks as crazy as this. However, we're just using this to practice because no matter how crazy it looks, it's just about typing it in. All right, so let's take a look at what's happening. So if I'm doing this question, okay, I'm going to just sketch it. So it has something like this. I'll change my color. And it looks like it's on the left-hand side. It comes down, you know, just a sketch. So it goes on forever like that. Now you can see it. Okay, so just rough sketch it. And honestly, when you are doing your work and your test, rough sketch it so you can see. All right, so let's talk about what is happening on the left side of the graph. So here's the left side of the graph. What is happening? Where is that going? To infinity. All right, what's happening on the right side of the graph? On the right side of the graph, where's that going? Negative infinity. So if I'm doing multiple choice, I need an answer that has opposites. So I'm going to come right here and get rid of things that are together. So if I look at just the y, right, because that's what I'm looking at, y is going to infinity and negative, right? When I come here, these are opposites, so that's fine. These are the same, so I can cancel that out. These are the same, so I can cancel both of these out. So it's either this one and this one. So it's just a matter of whether you understand how to read left and right. So let's talk about that. So if I'm talking about this left side, x is going where? So look at it. On the left, I'm going more negative, right? Towards where? Negative infinity. So that's how you write left. X is going towards negative infinity. To write right, x is going to what? Positive infinity. So now let's go look at that. As x is going left, is y going to infinity. So the option choices were going to be this one or this one. So as x is going, and right now it says right. So since I just said left, I'm going to go to the left one. As x is going left, is it going to negative infinity? As x is going left, is it going to negative infinity? No. So this is not the answer. This one has to be. As x is going left, is it going to infinity? Yes, it is. Okay. And I'm going to double check the other sentence. As x is going right, is it going to negative infinity? As x is going right, is it going to negative infinity? Yes, it is. And that's how you do these questions. So again, please decide on your answer before you start looking at the multiple choice because it can get a little bit confusing. Please go ahead and write down what you need right here. Okay. So what's the question asking to find? What's happening at the end? How will Desmos be useful to make the equation a graph so I can see? Where's my work? Oh, I guess I put my work right here. What is the answer? So you're definitely going to write, that one down, this final answer, this one right here, and then rate yourself on this question. All right, so that's end behavior. Let's take a look at axis of symmetry. All right, so we're going to take a look at the next one, which is going to be axis of symmetry. So you're going to click on axis of symmetry, and you're going to practice a question on that. All right, so they're going to give you whatever they're going to give you. I said specifically on vertex, so I'm going to choose the one that says vertex. So this is a vertex problem. Let me see if it gets hard. Okay, like that. Boom. It doesn't matter, okay? Whatever they give you, if it's an equation, do what with it? Type it into Desmos so you can see a visual representation. If I'm trying to find the vertex, I know by definition what it is. I just need to see it, right? So go ahead and type in exactly what you see, and please make sure you're double checking to make sure that you're not typing in the wrong thing. All right, boom. Where's my vertex? That's what it's asking. Where's my vertex? It's right here, Miss Ainley. My vertex is 4, 9. So I go ahead and put my answer in. And I have to write it as a coordinate, right? So I have to put parentheses, 4, 9. There's my vertex. Okay, boom. All right, so write some notes to yourself right here, okay? So again, if they give you an equation, doesn't matter how crazy it is, put it in. Then go look for the definition. All right, so I'm not copying that question down, but that's what you're going to do right here. All right, let's practice. All right, so now we're going to move on to the next part of the question. Find your maximum and minimum. And again, I don't care how hard they make this problem, okay? So I'm just going to go look for my maximum or minimum. All right, it doesn't matter. So all you have to do is just type it into here and see what it looks like, then go find it, okay? So it says it's going to be hidden from my view, and I have shown you how to do it by hand, but right now I'm doing it by calculator. So the form doesn't matter because whatever form it is, I'm just going to put it in the calculator and look. Okay, so if you remember how to do it by hand, that's fine. But if you don't, you're just going to type it right into the calculator. So, and again, please make sure you're typing exactly what you see, because what was that? So x minus 8 and x plus 2. All right, there's my quadratic. What is my minimum? Well, minimum is another word for what? The vertex only at the bottom, okay? So remember, when I go to the doctor, right, and I stand at the doctor, does he measure how wide I am or how tall I am? Hopefully you're saying how tall. All right, so which axis is the tall? It is the y-axis. So I don't care. I don't want to know what the vertex is. I'm just wanting to find out what is my minimum value, or the shortest I am, which for whatever reason I'm negative, but whatever. What is the shortest I am? What is the tallest I am? So I'm just negative 25 in this question. So I'm just going to put, hey, I'm negative 25, or maybe it wants me to say y equals. I'm not sure. Let's put it in together. Nope, I'm just saying it's negative 125. All right, so let's find another problem. Again, it doesn't matter which form. I'm just going to do one more to show you. So since I already did factored form, let's do standard. Okay. I have to wait, so let's wait. You know that vertex form, you can pull the vertex, but I want to do a different form. So that's why I'm choosing standard. But again, you can choose any form that you like. All you have to do is just copy the question in. So at this point, whether you know how to pull it or not, it doesn't matter, because I'm also going to show you how to do it with the calculator. So boom, I picked it up. Here is my form. All right, and again, I want to find my minimum. I already did my minimum, but it's okay. It's another minimum. It's right there. And again, it's negative 27. So I do want to do a maximum and show you that it's exactly the same thing. So let me find one of those. Similar problem. Minimum, maximum. All right, boom. And now since I've done standard form too, let me go ahead and do vertex form, because why not? All right, type it into the calculator. And some of you have already seen the vertex before I have, right? Because I'm still typing, and if you know it, that's great. But I am just teaching how to use this calculator. All right, so I already know my answer is what? 32, right? We're just going to prove it with the calculator. So here we go. Here's my vertex, right? Remember how tall you are. So it doesn't care how wide, how tall. So just the y value. So it's 32. So you see, you can get it right out the calculator, but some of you were able to see that really fast without me even typing it in, which is fine. Whichever way is okay. All right, so that's it. Let's practice. All right, so we're going to be taking a look at, and please correct this, it will all be question 11A, B, C, and D. This is all question 11. All right, so I want to take a look at how to select form to find quadratic feature x-intercept. So today we're looking at x-intercepts. All right, yes, you should already know that factored form is the quickest way for you to get the x-intercept, but let's assume they give it to you in a different form. So here's the equation they give you today. They ask you find the x-intercepts. Go ahead and just type it in and look at it. So we're going to have x minus 3 squared, all right, plus 25. And where does it cross the x-axis? At -2, and at 8,0. Please write down an explanation as well as a question here on how to find x-intercepts. All right, now let's also cover just looking at the graph and seeing what it is. So we already know these two answers are that. All right, now we're going to just cover looking at it. We know that what is the form that you want to look at, so you can just pull the x-intercepts, the roots, the solutions, the zeros. You want to look at factored form, right? 2 parentheses. Now pull it for me. You take the opposite of the parentheses. So it's going to be -2, which you can see is -2 right there. And this is going to change from -8 to what? +8. So you can do this with and without a calculator, just depending on what they give you. Let's practice. Select form of find quadratic feature, and we're looking at positive and negative characteristics. So again, there is certain ones that are best for it, and I'll show you by hand and by calculator. So for right now, let me go ahead and show you for calculator. So I'm going to pick any form. It doesn't matter which one it is, and we're going to just straight put it in the calculator. So this is what we have in the calculator. All right, boom. All right, so the question is, when is it positive? That means it's above the x-axis. What does that relate to? So x is greater than 0. Sorry, not x. I apologize. Y. All right, so above the x-axis, above the x-axis. All right, so what part of this graph is above the x-axis? Do you agree that it's from here to here? At every single point between these 2 points, it is above the x-axis. So what I'm going to tell you is this. If it's joined together, like it's together like this versus separate, like this is below to here and then below to here, this is going to be one equation. If it is below, so let me give you the other situation. I'm going to do a below one. You can see that it's split up. It's below right here, then it stops being below, it goes above, then it begins to be below again. So these are 2 separate equations. So again, if your points are connected like this, that's one equation. If they're 2 separate ones, that is 2 equations. So before I show you how to actually answer this, I'm going to give you a few more examples of that so we can get familiar. All right, so remember, we're just looking at, this is my cutoff point right here. All right, so if I'm looking above, that's above the x-axis right here. How many equations do you see? 1, 2. If I'm looking below, that's below the line right here, you see that it joins together to be 1. All right, we're going to practice a couple more problems like that. So if I said above, how many equations do you see? 1, because it just joins together. If I said below, it's this point right here or this point right here. Let's practice a few more. Again, if I said above, so you look on the top, how many? 1. If I said below, how many? 1 and 2. Okay. All right, let's practice another one. All right, here's another one. So again, if I said above the x-axis, what do you see above? You see 2 sections, right? Here or here. And if I say below, then you see just this one section. All right, so I'm going to go back to my question. All right, so I'm going to go back to my question, and I've gone ahead and put the above or below. I'm going to answer both questions. So let's see if this is when it is positive. All right, so when is it positive? It's supposed to be above. So I'm going to shade that. So I'm going to do this real quick. Greater than 0, so I can have a visual, right? So this is above. And how many bits of the graph do you see? Just one connected part. So because I see one connected part, it's going to be between these 2 points, which is between what? 1 and 5. All right, now I have 2 options on how to write this out. Okay, so I can say it's between 1 and 5. So what is between 1 and 5? X, my x coordinates, right? My x coordinates are between 1 and 5. Now I don't include 1 or 5. Why? Because it's negative, then at 1, it stops being negative and starts being positive, but there's this turning point. So you can't include my turning points. All right, so it's between 1 or 5, and you can write it also as 1 to 5. All right, but one answer. Why? Because it's a continuous. So it's positive one answer. Okay. Now, if the question was, when is it negative? Okay, my two numbers are still 1 and 5, but let's look at it. So let me change this to be negative so you can see it. All right, now I'm going to write my answers. Okay, so I'm going to say when x is this to the left or to the right of this one? This graph right here. Is it on the left or on the right? I'm going to say left. And if you look at the arrow for left, it goes in this direction. So I'm going to say, hey, it's on the left of, what was that number again? Was it 1? It's on the left of 1. Did it shade the part that I need? Yes, it's negative right here. So it's going to be, this is for my example. Of course, you need to write yours. Negative on the left. So if I was writing in this notation, I would say x left of 1 or less than 1. Or I could write, hey, you're negative until you reach 1. So that means where you're coming from. Negative infinity, open, open. Okay. Or, so there's two answers because they're 2 times, right? Or it's also negative here, right? So how do I write that down? So let's try a different number. So we want to say 5. And you see it's shaded the wrong side because it's supposed to shade this black line, right? So I just need to change this direction. So you see it's to the right of 5. So it's to the right of 5. Or you can say, hey, I'm going to start being at 5 because I start being negative at 5. And then when do I stop being negative? Infinity. All right, so this is going to be 5 to infinity. So you can see that you can use Desmos as a visual representation of your question. Okay, let me go ahead and try another question really fast. Maybe it's not letting me. So we're going to use Desmos to check our answer. And you can see I used a different form, so it doesn't even matter which form you use. So this is 3 parentheses x minus 3 squared minus 12. All right, cool. So here's my equation. And my question is, when is it negative? All right, so looking here, right? This is my point right here. When is this graph? When is the purple graph underneath my mouse? It is right here. So we can agree how many answers am I going to have? 1. If the question was above, it'll be this answer here and this answer here. So we can use Desmos to check my situation. So I wanted to shade this negative piece right here. I want Desmos to do the work for me. So I'm going to grab my 2 points. So I'm going to tell Desmos, hey, it's 1 and 5. Hey, Desmos, graph, let's see if I do this right. Because I know it's one equation. I know I need to do x is less than, or x is greater than 1 and x is less than 5. And perfect. You see, it shaded the bit I need. So this is my correct answer. Now let's assume that the question was, so this was if it was negative, it's negative here, 1 time connected. Now let me say the question is, when is it positive? I know I should have 2 answers, where it shades this line here and it shades this line. So I'm going to try it again. So let's say x is to the right or greater than 1. Did it shade the line that I need? No, it shaded down here. So that's not it. So let's go ahead and try and change this around. So this is if this signs confuse you, you can use Desmos to check your answer and boom, it shaded what I need. So it's this or, the other number is what? 5. All right, let's try it. Let's try it this way. Ooh, no. I don't want you to shade this. I don't want to shade that. I just want you to shade this part of the line. Let me zoom out a little bit so we can... Boom. I need you to shade this part of the line. So that must mean I must have the wrong directions. Let me change it right there. Change the direction to the right. And it works because you see, now my shaded part is a positive. So what's the only thing that's shaded, look, is my positive side right here and right here. None of my negative is shaded. And that's how you know that your answers are correct. Again, the big takeaway when you're looking at positive is you're looking either above the x-axis, below the x-axis, and your answer will either have 1 equation if it's connected or 2 separate ones if it's disconnected. Let's practice. All right, so last one we're going to take a look at is select form to find the quadratic feature. And technically, I'm looking at increasing and decreasing. So I'm just going to make sure that that's all I cover right now. So I'm going to go to my problem, increasing and decreasing. All right, so I'm going to do an increasing one and I'm going to do a decreasing one. So just hang tight until you get the one you need. So again, increasing and decreasing, there's a form that makes it easy, but it doesn't matter because what? I'm putting it where? In the calculator. So 2x squared minus 8x minus 24 right up into the calculator. And again, make sure you're typing exactly what you see, and that is why you double check, Miss Ainley. All right, so look at my mouse real quick. Okay, what is my mouse doing from left to right? What am I doing? Going where? Down. Until I get to what point? This point, and then I start doing what? Going up. So that's what you first have to ask myself, okay? I'm going down, then I'm going up. The shortest way that I know how to teach this is going to be real simple. What was that point of turn? It was my vertex, right? So let's start off with my axis of symmetry. So we know my axis of symmetry is x equals what? 2. And we're going to write that down. X equals 2. And it should produce my axis of symmetry. Boom. Because it splits my graph, right? On the left of it, it's going down. And then on the right of it, it's doing what? Going up. So all I have to say to tell the person who's grading this is whether it's the left side I want or the right side. And it depends on the question. So if this question is saying increasing, which side is increasing? Is it the left side or is it the right side? And you should have said the right side. Now just think about this for a quick second. Let me show you what the right side looks like. So this is the right side, okay? Look at the inequality piece of going to the right. That's what you change the equal sign for the axis of symmetry to say greater than. And then you're going to do it in Desmos. Why am I doing it in Desmos? Because I want to make sure it highlights this. Because let's say I said it was 6. All right. Is it not increasing here? Yes, it is. So I know that I've made a mistake. So whatever it is, you're going to put your answer here so you can double check it. So it is increasing to the right of 2 when x is greater than 2. And that's what you're going to type right here. When x is greater than 2. All right, now we're going to also take a look at decreasing. And again, please don't try to memorize these problems because it will not work. It's going to change every single time. You see, this one is a U. Another one you may find an N. So let me see what this one is. Again, I'll choose a different form just so I can tell you it doesn't matter. So it's going to be -3. And then in parentheses, we're going to have x minus 3 and then x plus 5. All right, look, now instead of it being a U, it's an N. Okay, so that's what I'm saying. Don't memorize it. First thing you find is find the axis of symmetry. Boom, which is my vertex, right? So x equals what number? -1. I'm going to write that down. X equals -1. There's my axis of symmetry. Boom, it has split that thing in half for me really, really well. Now I just need to see which part is increasing and decreasing. So I'm starting on my left. Follow my mouse. What am I doing right now? Increasing, right? Till I get here. And then what do I start doing? Decreasing. So now I just need to know what is the question asking. So I go to the question, hey, Miss Amy, when's the graph decreasing? Well, I know it's not the left side because what's happening right here? Increasing. Then it starts decreasing. So I want to say on the right. So it looks like it's the same arrow. So I'm going to go ahead and change my equal sign to say, hey, the right. And boom, it shades it in for me. That is true. Everything on where it's shaded is doing what? Decreasing. Now, let me just show you the other arrow. Let's say that the question wasn't asking where it's decreasing, but where it's increasing. So where is this increasing? Again, you start with the axis of symmetry. Excuse me. And then you say, where is it increasing? So it's increasing on this side. So I want to say that it's increasing on my left side. So here's my arrow. Look at the arrowhead. Go duplicate that on Desmos. So I duplicated. Did it shade the right side? Yes, it. So then I know that that's the answer. At every point on this graph, it is what? Increasing. Because after here, it starts decreasing. So please use Desmos to check your work. So when you're answering this question for 17D, which is right here, all right, how will Desmos be useful? To check your answer. It's going to be useful to check your answer to make sure it colored the correct side. So once again, please make sure that you did complete your notes. Let's practice. All right, so we're going to take a look at IOA 6D, relate domain and range in a quadratic function to its graph where applicable to the quantitative relationship it describes. You can see very clearly it's going to be 2 questions, 12 and 18. There's no delta math to practice. So what we're going to do is I'm going to do this one, and then you're going to do this one and show it to me, okay? But you can work together in groups. All right, so these real world problems, you kind of have to think through whether it's possible to have certain situations. Now, the reason I put the graph here like this is really, if they don't give you a graph, you just type the equation in here and you'll see the graph, right? So we're going to talk about a couple of things. All right, for one, remind me again, what is domain? All right, you should have said, so this, what is the question asking you to find? It's finding domain and range in context or in the real world. How will Desmos be useful? Only if it's an equation to type in to see the graph. All right, so here's my work. So let's talk about it. Okay, so domain is which axis? It's x-axis, and then from where to where? Left to right, right? So we're going to focus on that for just a second. All right, so domain is x-axis for left to right. So I shouldn't be looking at any other axis except from the x-axis for left and right. Now, before you answer that the domain is all real numbers or negative infinity to negative infinity, just because you see arrows, remember this is a real world problem. How do you know that? Because it gives you a story, okay? So it's giving you a story. You have to think through what this story is saying. So let's look at it. The rocket is launched from a tower, okay? So this is a rocket that is launched from a tower. The height of the rocket is y in feet. Okay, so I know that this is the height. So we're going to go ahead and say that. That's the height in feet. The time after the launch, x in seconds, is given by the equation. Okay, so I think I put the equation. So again, if they gave you the equation, type it in here so you can see the graph, but I think I just gave you the graph. All right, so x in seconds, so this is going to be x in seconds. All right, so which is what time? All right, now let's just think about this for a second before we even start talking about domain and range, right? So domain is left to right. So yes, there's a graph right here. There's a graph going to negative infinity. But let's think about it for one quick second. I am looking at the x-axis, which represents what? Time. So my question to you at this point here, right here, -2. Can I have -2 seconds? No. And that's why in the real world, domain is not from negative infinity to positive infinity. You just have to think through it. All right, so my question is, can I have 0 time? Yes, and there is a graph at 0. Therefore, my domain can start at 0, okay? So it's from left to right. All right, how far can my domain go? So let's see. There's an arrow here saying it goes forever to infinity, but let's think about it for a second. I can have 100 seconds, right? Can I have 200 seconds? Can I have 300 seconds? Can I have 1,000 seconds? Yes. But let's also think about what's happening in this question. It's a rocket. It goes up, then it goes down. What does it signify when it hits the x-axis? The ground. Can I go below the ground? No. Well, I mean, okay, it can kind of go a little bit, but no. In real life, all right, the rocket is not going to go below the ground. So we cannot look at this part of the ground because it doesn't exist because it's negative height. So this part right here doesn't exist because it's negative height. This part right here doesn't exist because it's negative time. So this is really my graph. My graph is going from here to here. And now that I've said that, what would be my domain? From 0 to, and now that I put all this writing on it, what's that? Maybe around 9. All right, if you have an equation, you're going to have an exact equation. You're just going to put it here. So let me give you an example. Let's say this was your equation. And again, I'm just making this up real quick. So let's say that is your equation. There will be a specific number, and you're going to use that one, okay? But this one is a graph, so I'm using an estimation. All right, so my domain is from 0 to 9. Now, does it include 0? Yes, because I can have 0 seconds, and the height at 0 seconds is what? Something about 50 that looks like halfway, about 75. Okay, so yes, I can have 0. Can I have 9 seconds? Yes, because my height is what? 0. Okay, so boom, I can have that in that notation, or I can write it in this notation because I'm including, I put the equal sign, 0 to 9. All right, what you're going to do real quick is pause the video and try to do domain for this second question. Okay, pause the video, try to do domain for this second question. All right, now that you've done that, let's just talk about this since it's fresh in your head. Describe what domain means in the context of this problem. So I go from 0 to 9 seconds, but what does that mean? That means the rocket started traveling. The rocket was launched from 0, and then from 0 seconds, it was launched, and then it landed on the ground at 9 seconds. And you're writing some kind of sentence that says that. Please make sure, because it's domain, that you're using time. All right, so with domain, when you do the explanation, I need the x-axis, which is time, and then you're telling me what's happening with the real world, which is a rocket. So something with time and the rocket between 0 and 9. Okay, so you can say domain in this context represents the time it took for the rocket to be launched and then for it to come back down to the ground. Something like that will work perfectly. All right, now let's take a look at the range. Okay, so range is from where? Range is from the bottom to the top. And which axis am I looking for? I'm looking for the y-axis. Okay, so bottom to top. All right, so let's look at the bottom. So like we said, right, there is a bottom, right? All of this, there's a bottom right here. But can I be over here? No, we just stated why we cannot be there. So the absolute bottom of the graph can be the ground, right? Now, can I include the ground? Yes, because here it lands right back here. So even though it doesn't start till here, it does land back on the ground. So my range is going to be from 0, and I can include it to where? Where's the top of my rocket? Right here, which is what? 350. All right, do I include 350? Yes, because at 350, oh, I'm sorry, that's not 350 because it clearly tells me what it is right here. Can I say that it's 350? Absolutely not, because does it get to 350? No, so I have to say 349.77, and it includes that. Okay, to write it in the other notation, oh, I wrote X. I am really tripping today, y'all. It's Y, because it's range, okay, and then it's between 0 and 349.77 seconds. So again, can I write 350? No, because it does not reach 350. All right, let's talk about what does that mean in meaning. So again, you need to describe that here so that you know how to do it on the test. In meaning, so range is from the bottom to the top. So then I'm talking about the height, right? So we're looking at the height in feet. Okay. So I need something that describes, okay? So I need something that talks about, let me change my color. I need something that talks about height, right? And rocket. And you can mention, you know, from 0 to 349. So I can say, okay, the range in this contest represents the total height that the rocket reached from the ground to 349.77. Something along the lines of that, okay? And if you want to measure time too, that's fine. But as long as you say something about the height and the rocket, okay? So the rocket the rocket was launched at 50. It reached a maximum height of 349.77 before coming all the way back to the ground. There's another sentence, a little bit longer, but it all works. All right, so now you're going to complete this question, and then you're going to come and show me. Let's practice. All right, so next we're going to take a look at average rate of change. So average rate of change, estimate, calculate, and interpret the average rate of change in a quadratic function represented by a graph, a table, or an equation, and make comparisons to the average rate of change of the linear function. So that's 6.g AKS. And so as you can see, we are going to find average rate of change from a graph, a table, and an equation. It really doesn't matter which one you're finding it from. We're going to, again, go to our reference sheet, our formula sheet, and we're going to find average rate of change. It's right here at the top. What does it say? The change in the y value divided by the change in the x value for two distinct points on the graphs. And what does that sound like? It sounds exactly like the slope. The change in the y2 minus y1, divided by the change in the x, x2 minus x1. The only difference is that it has two distinct points on the graph. In other words, they're going to give you x2 and x1. That is it. So we're going to start off by putting this in our calculator. So we're going to go ahead and type it in, and I'm going to say it again. I've said it in class 1,000 times. Press divide first. Press divide first. Do you hear me? Press divide first. Press divide first, because if you don't, it's going to look really funky. So please press divide first. I hope you understand that without me having to sing my wonderful song. So we're going to go parentheses where y2 is, minus another parentheses, which is going to be our y1. So we're just setting it up for no matter what the question is. Then parentheses minus parentheses. So basically, all that we're putting in this parenthesis is y2, y1, x2, x1 in that order, regardless of what the question is. So since we're finding three different average rates of change, I'm going to go ahead and copy the question. But actually, before I do, remember the only difference between slope and average rate of change is that for average rate of change, because it's not a linear line, it's not a consistent or constant rate of change, there are two distinct values that they give you. So before I copy it, let me figure out what are the two distinct values that they give you. This one, I want you to do it right off the notes first. So again, as I'm doing this question, you're doing this question. So you see it's going to change. You see the numbers are different. So we're going to do our questions together, but you're going to copy my answer on your sheet of paper. Okay, so you're doing your question on Delta Math as I do this question on Delta Math. All right, so let's go ahead and get started. So what are our distinct values? So for me, it's -2 is x1. So this is the first x value. How do you know it's x, Miss Amy? Because it says x right here. This is the first one, and this is the second one, because this comes first and this comes second. All right, so once again, according to the formula, which one goes first? So that goes on the bottom. The second one goes first, then the first. So you must make sure you keep that order. So the second one goes first. So 4 goes first. So I'm going to put 4 right there. And then on the next one, the first one goes first. So I'm going to put -2. And please make sure to type in exactly what it says. All right, since I know I'm going to do this 3 times, I'm going to do it 3 times. So here are my 3 times. And I'm going to do it in order just so I don't get confused. So f of x, g of x, h of x. So I can see this is h of x, g of x, so this one must be f of x. So I'm going to do it in order so I can, compare which one is which. So starting with the graph. So if you're looking for average rate of change from a graph, you're looking at what does 4 match up with. Remember, this 4 is an x. So if I look at my graph, I know that this is x and this is y. So I'm going to go where x is equal to 4. It's right here. And I'm going to go up or down until I meet the graph. Well, if I go down, I'm not going to meet the graph, right? But if I go up, I meet the graph right here, right? So wherever you meet the graph, that's where you're going to go to. And that you're not going to go left, right. You're going to go straight up. So straight up and down wherever you meet the graph. And when you meet the graph, you're going to stop and go either left or right to the y-axis. So this is going to be what? It's between 40 and 60. Well, let's figure out how it's going. It's going 10, 20, 30, 40, 50, 60. So this is 50. So 4 matches with 50. So 4 matches with 50. When x is 4, y is 50. Now I'm going to find out what does -2 match. So again, remember, this is your x-axis and this is your y-axis. So I'm going to go to where x is equal to, what number do I need? -2. So x is -2, it's right here. Then again, I'm going to go up and down, directly up and down. So there's nothing down there. But as soon as I hit the graph up here, I'm going to stop and go to the y-axis and see that my number matches with 20. So when x is -2, y is 20. So I'm going to go ahead and put that. So there's my average rate of change for 2 specific values for f of x. So this one is f of x. I'm going to go next to g of x. This one's a lot easier. I'm looking for 4. When x is 4, y is what? 5. When x is -2, what's g of x? 53. There's my average rate of change for that one. When I go to an equation, okay, I don't have any numbers, Miss Amy. That's cool, because we all know we can make this a table and then it can become this one, right? So we can go ahead and do that. So we're going to type that in. So h of x, and you really don't have to type in the h of x, but I'm doing it anyway. Negative x, the thing about this question is please make sure you copy correctly. So double check what you copied to make sure that you're right. And I want to make it a table because we agreed the table one's quick. How do I make this a table? Well, we press all the buttons and see what happens. So if I press this and I click this, that did not help me with this question. So I'm going to say that's not it. So I'm going to undo that. I'm going to click the next thing. So click this. Oh, look at that. I can click table right here. So play around with the buttons, especially if you forget how to do it. Now, what am I looking for? I'm looking for 4 and -2. So I'm just going to type 4. Okay, maybe highlight it. 4, and then come to this one and type -2. Boom, I got it right there. 4 goes with what? -24. Put it in my formula. -2 goes with what? 0. Put it in my formula. So here's my average rate of change in a row. So in this question, please don't skip it saying, oh, you know, it's a lot of work. It's not. If you're putting it right in the calculator, it's very, very quick. All right, so put it right in the calculator. And what is my average rate of change? Now, I do want you to write this work here. So you're going to write these numbers here so that you know what it goes with, because this is the question that I gave you. And then once you do that, so again, to be clear, I'm saying you're going to write this down. Okay, that. And what's that equal to? 5. And you're going to repeat the same thing to that. This one's equal to -8. And this one is equal to -4. Okay, so please just make sure you are writing down what you are doing. And again, what is this question asking you to find? How will Desmos help you? Where is the work for it? So you can put the work here or you can put the work here, wherever you have space is fine. What is your answer? Rate yourself on this topic. You're doing that for every single question to make sure you're okay. All right, so let's read the question. Now that I've done all the math, let's actually read the question. What is it saying? So it says the function is blah, blah, blah. Select an option that represents the ordering of the function according to the average rate of change from least to greatest. That means the smallest number goes first. So there are going to be 2 types of questions that you're going to get. From least to greatest, so I'm going to answer this question. What is the smallest value? So if you're looking at a number line, and if you don't know what a number line looks like, that's okay. Just go ahead and pull up Desmos again. And you're going to look at, I'm going to hide this real quick. Maybe zoom out. So click home. Boom. Here's a number line right here. So which one comes least? The one furthest to the left. 5, -8, or 4. So I can see -8, -4, and then 5 is going to be on this side if I zoom in. Okay, so that's the order. So the -8 is first, then the -4, then the 5. And that's all you're going to write down, only using their functions. So it's going to be h of x, then, oh, I'm sorry, not h of x. I'm just checking to see if you're listening. G of x is first because it's -8, then h of x, and then finally f of x. So if they ask you to order it least to greatest, that is it. Sometimes what they'll do is they'll ask you to write which one is growing the fastest, but it doesn't matter what direction. So they won't say which one is growing, which one is increasing the fastest in the positive or in the negative. They'll just say which one has the fastest average rate of change. When they do that, they don't care whether it's a negative rate of change, whether it's decreasing really fast or whether it's increasing really fast. All they care about which one is changing the fastest. So if the question was, what is changing the fastest? And so now you're going to split this in half and you're going to write, so there are 2 kinds of questions you're going to get. You need to know how to do both. So which average rate of change is the fastest? So without mentioning direction, I'm just asking which one is changing the fastest. Then the negatives or positive don't matter. So which one is changing the fastest is going to be the absolute value of -8. It's going to be g of x first. Then which one is changing second fastest? Negatives don't matter. It's going to be the 5 is bigger than 4. So that's going to be f of x. And then finally, h of x. So again, very important that you understand the difference. So which average rate of change is changing the fastest? Direction does not matter. Order them for least to greatest. Direction matters. Okay. All right. That's it. Let's practice. All right, you guys already know we've talked about how to factor trinomials from a calculator. I'm just going to give you a quick refresher before I show you how to do it by hand. These are the steps to do it by hand. I've gone ahead and typed in my equation, my quadratic equation into here. So I already know that here are my solutions. Boom, those two are my solutions. So I'm going to write into factor form. I know that I should have 2 parentheses for factor form or slope or intercept form, right? And as soon as I do that, you see it goes off whack because I haven't put it in. So the key thing to remember is that you take your solutions, your roots, your zeros, or your x-intercepts, and you change them into factored form. If it's going into the parentheses or out of the parentheses, you need to change the sign. So we're going to change this from -1 to what? +1. And we're going to change, and as soon as I did that, you see how that lined up? So I'm good so far. This one needs to go to -1.5, but we know we don't put -1.5 in there. We don't accept it. We have to have a what? A fraction. So you're going to click fraction. Now be careful. This is exactly 1.5. It's not -1.5555. So you got to read. If it was 555, right, you would look at this answer and be like, this makes no sense. What would you then do? You would keep going till the answer that makes no sense is gone, and then keep going until it comes right back, and this looks like a better number. But for this particular question, it is literally 1.5. That is what you're doing. What do I do now? So I can't write, all right, so you take the opposite. I can't write this. I have never seen a quad. It lines up, but this is not how we write it, right? So remember, you take your denominator and you put it where? In front of the x. That's all you got to do. You take your fraction, you take your denominator, put it in front of the x, and please make sure you change the sign. And as soon as you do that, you see my solutions have lined up. But here's the problem. This cannot be the answer. Why, Miss Ainley? Because the graphs just don't match, right? So we got to make these graphs match. And remember, we talked about if they don't match, it means that there's a what? A GCF. All right, the calculator is going to help you find the GCF. Don't remember how to type it in. At least just type in GCF and then click it. It says try using parentheses. Let's try using parentheses. GCF of what? Of the question. All right, so what are the numbers in this question? It is 4, 10, 6. And the GCF is 2. And all you have to remember to make these graphs match and to write in correct factored form is to put the GCF outside the parentheses. And as soon as you do that, what happened? It lines up perfectly. All right, so that's how you do it with the calculator. But now we're going to talk about how do I do the exact same thing but using my hands on my head. Okay, so no calculator basically. All right, so here are the steps. You're going to put them in standard form. So in other words, it needs to look like this: ax squared plus bx plus c. It already does look like that. There's ax squared plus bx plus c. Cool. All right, factor out the GCF. So we're going to factor out the GCF. We did that. You just type in GCF, blah, blah, blah. It's 2. All right, so the GCF of that is 2. And then it says, if you don't do this here, you'll get the question wrong. And write it where you will write your final answer. So we're going to go ahead and write it. So my answer is going to be 2. And I have 2 answer places right here. I'll just put it right here. Okay, so just write it where you put in the answer. And you could write it over here as well. You know, what's the question asking you to find? How does most be helpful? You work your answer and rate yourself. Okay, so boom, I put it right there. I can forget about it. Circle and label ABC in the question. So circle and label ABC. So if I took out the greatest common factor, I now have 2x squared left in the parentheses plus 5x plus 3. And that's just by taking out 2. When I take out 2, if I distribute it back in, I should get the original question back. So that's what taking out the GCF means. So this is A, this is B, and this is C, right? So label it. All right, don't forget the symbol or the invisible 1. Okay, so what it's saying is, let's just make sure, let me change my color real quick, that I take the symbol with whatever the number is. And if there was a 1 there or nothing, it'll be an invisible 1 because it does exist. All right, fill out the top and the bottom of the x according to the picture. So here's the x. The top says A times C. So what's 2 times 3? 2 times 3 is 6. What is the bottom? Just B. So what's the bottom? 5. So we're filling out the picture just like what I see. All right. Find the factors. Okay, so these are factors. These are 2 numbers that multiply to AC. So they need to multiply to 6 and they add to 5. And so what you're going to do, and I think you can do this part in the calculator. Let's go ahead and do it. Factors. Let me see. Factors of, what are they? The factors of AC. So factors of, and again, we want to put parentheses or whatever we want. So A is 2 and C is 3. No, factors of AC. I'm sorry. I'm tripping. Factors of AC, which is 6. Okay, so no, that doesn't help me. Too many variables. Maybe factor of 3. Okay, I guess it's not going to let you down. So basically 1 times, so it's kind of like breaking it down. So you're going to do this. You're going to say, okay, 6 divided by, and you're going to check 2. Does that work? Yeah. So what we're saying is 2 times 3 is a factor. Okay, cool. Let's check another number. Well, there's no point of checking 3 because we already know. Let's check 4. 4 didn't work. Check 5. 5 didn't work. 6 works. So 6 times 1. So the only factors, and you can just go in order, is 6 times 1 and 2 times 3. So these are my factors, right? But they also have to add up to 5. So it says find the factors and multiply to AC and add up to B. All right, so now all I have to do, okay, is change the signs so that they can add. So I know both of these multiply to 6. So what I'm going to do is I'm going to take this first one. So once I take that first one, so this is 2 and 3. So remember, they already multiplied to give me 6. I now need to add them to give me 5. So I'm going to put plus. Oops, plus. Okay, I need them to be 5. Oh, look at that. So the first one, 2 plus 3, gives me 5. So 2 times 3 is 6. 2 plus 3 gives me 5. So my 2 answers, that actually works. My 2 factors, right, that multiply, so check the factors and fix the signs, that multiply to 6 and add to 5 are 2 and 3. So we're going to say 2, oops. So my factors are 2 and 3 because 2 times 3 is 6 and then 2 plus 3 is 5. And so just be careful and play with the signs. So if that wasn't it, what you would do is put a negative here. Does that give you the answer you're looking for? No. Put a negative on the second one. Does that give you the answer you're looking for? No. Put a negative on both. Do they give you the answer? No, it's close, but it's negative, right? So be very exact. So you're just going to change the signs of both of your factors and see which one works. But I already found it as 2 and 3. So now what? Now we're going to divide by A. So what is A? All right, so remember my A labeled is 2. So now you're going to divide by 2. All right, now put that in the calculator. 2 divided by 2 is going to give me 1. And then 3 divided by 2 cannot give me anything. And these are your solutions, okay? Only thing is you don't have to change anything because they're already done for you. So my factors are going to be x plus 1. And we already know that this needs to come to the front because it's a fraction. And this is 2x plus 3. And if you notice, that's the exact same thing we did when you did with the calculator. So if the fact is a whole number, just write your answer as GCF, x plus left, and then x plus right. If it's a fraction, then you need to remember to put your denominator, your left denominator, in front of the x, and then your numerator as what is left. Okay, so that's how you do it by hand. Let's practice. All right, so what we're going to look at right now is complete the square with an even b, and that just means that the number with the variable is even. That way we'll have no fractions in our answers. But just like everything else, I am going to show you how to do this by hand. Like everything else, if you're given multiple choice, you're going to just go ahead and type it straight into the calculator. Before we do that, we're going to make one little correction. There was a typo here. We're going to cross out that 4. This was actually supposed to be the question. So let's go ahead and type the question into the calculator. And this just goes for any single thing you have that's multiple choice. Go ahead and type it up and see if you can find a match to it with the answer choices. So boom, there's my quadratic equation. Now I'm going to type in my answer choices. So there's my first one matched. All right, so my first answer should be A. All right, so now we're going to go ahead and do it by hand. Okay, so that's how I use the calculator, but also doing it by hand is also pretty quick. So we're going to go ahead and, knock that out. All right, so we're going to take the constants. And what is a constant again? Anything that does not have a variable. So that's going to be -18 and -6. Does not have a variable. Those are my constants. Take them to the right and combine them. All right, so I'm going to add 18 on both sides so that this goes to 0, and what I'm going to be left with is x squared plus 10x, and I'm going to leave a space here, and you're going to see why in a second, and put this in the calculator. 18 minus 6 is 12. Okay, all right, take the constant on the other side and combine. I've taken the other side, I've combined them. Take b, and again, b is the number with just the x, so that's going to be the number with just the x, so take b right there. All right, you're going to divide it by 2, and then square that result. So take b divided by 2, square the result. So 10 divided by 2, so we're going to divide 10 by 2 is 5, and square that's going to be 25. And you're going to add that number to both sides. So I'm going to add it to this side and add it to this side. And again, I'm just going to show you that in the calculator. So again, you're going to take b, which is 10, divided by 2. Let's subtract, Miss Ainley. Divided by 2 right there and square it. What's 5 squared? And if you want to square it here, don't do... Wait, let's see if it'll work actually. Yeah, close the parentheses and then square it. It will work. Yeah, that's it. All right, so either do it separately on 2 different lines. So 10 divided by 2 is 5. So 5 squared is 25. Or just close the parentheses and do it there. All right, so it's 12 plus 25. And again, you can use a calculator. It's going to be 37. So, oh, I'm getting ahead of myself. Let me read the instructions. So we took divided by 2 squared, add the number to both sides. On the left, write this. So we're going to write x in parentheses. And then it says plus or minus depending on what b is, right? So what's b? B is positive. So I'm going to write positive. And then b divided by 2. So only b divided by 2 here. So 10 divided by 2, which is 5. Close the parentheses and then square. And on the right, combine the constants, which we just said was 37. Okay, and that's it. So that answer, you can see, matches with A. So doing it by hand is just as easy. The first step is to make sure all the constants are on the right, combine them. Then you're going to take the one with the variable with just x. You're going to divide it by 2. It's going to give you the answer here. Square that, which is going to be 25, and add it to both sides. And you're done. Okay, let's practice. Right, so we're going to take a look at how to compare characteristics of 2 functions. You can be doing linear and quadratic, quadratic to quadratic. It can give you any kind of thing, each represented in a different way, algebraically, graphically, numerically, tables, or even by verbal description. So you just have to know how to compare whatever it is. So let's look at this. This is a graph. This is obviously quadratic. How do I tell if this is quadratic or linear? Well, are you adding the same thing? Is it a consistent rate of change on both sides? Yes, it is. So I know this is linear. But again, you don't have to know that, right? We can come right up into Desmos and put it in so we can compare apples to apples. So we can make this table into a graph. How would I put in a table? Well, if you forget, you're going to click everything. So that's not it. All right, so I guess I click done. All right, that doesn't do that. Okay, done. That hides it. That's not it. Oh, boom, table. So please don't be afraid to click on something just in case you forget. And what we're going to do is we're going to copy this table verbatim. And you can see it's already caught the pattern. Just keep pressing enter. And now we're going to put in this one. Please make sure that when you're doing this, though, that you are literally making sure that you're typing the correct thing. All right, because if you make one mistake, it will take it out. All right, so what does that look like? It looks like a straight line, which is called what? A linear function. All right, so the first question that it's asking is which one has a larger y-intercept? Okay, so what does that mean? Where it crosses the y-axis. So the first one, all right, f of x, so we're going to call this f of x. I might not have labeled that. This is f of x, this is g of x. All right, so the first one crosses the y-axis right here at -2. So again, you are writing what is the question asking, can Desmos help, blah, blah, blah. You're doing that right here, okay? So what's the question asking me to find? The largest y-intercept, blah, blah, blah. But I'm just going to do it right here. So my f of x is -2. So f of x is equal to -2. What is the y-intercept of g of x? Now, there is a shortcut that I taught you how to do that here, but if you don't remember it, you're going to come right here, and that's where it crosses the y-intercept at 0, what? -4. Okay, so at 0, -4, so it crosses at -4. All right, now, what if they didn't give you that? Well, we can make this into an equation so we can see it, and this, we said, looks like a what? A straight line. How do I make this table into an equation? I go y sub 1, because it uses 1. Then I go squiggly line, all right, and you can get this right out of a formula sheet, except for the 2 things you needed to change, mx sub 1 plus b. And you can see that it will give you your answers, -1 and -4. So when I want this, I want to know what this line is, I can come here and I can type y equals -1x. And what do we have next? -4. And you can see that, let's change this, highlight that, hover your mouse there and press long press, I'm sorry, then click that. You can see that purple goes right over green, which goes over red. Okay, so I can take this out because I no longer need it. This is my equation. I can take this out because I no longer need the table, because now I have the full graph. So if they didn't give me the y-intercept, I can make it to where I can see it into an equation, and then I can press what? I can make it a table, right? And then I can see everything that the table is. So look, it matches, right? So it starts at -2, -2, -1, 3, 0, -4. Okay, so once I have the equation, I have everything I need. So here is my y-intercept. Here's my x-intercepts. Now I can compare all kinds of characteristics, even if the value is not in the table. All right, so which function has the larger y-intercept? Okay, so which one is bigger? So let's look at the y-axis. So bigger is higher up, right? Is -2, and I'm just going to zoom in till I can see this thing going up by 1. Maybe not like that. I'm going to hide this real quick. Going up by 1. So there's going up by 1. So this one is -4 and this one is -2, right? Which one is bigger? Well, the one that's higher up is bigger. So -2 is bigger. So which one has the larger y-intercept? It's going to be f of x. And y, by how much? So if it's here and I need to get to -2, I'm going to go 1, 2. So by 2. Okay. And the way that you can do that, you can also do that in the calculator. Okay, so which one is bigger? You're going to do, all right, so the one that's bigger minus the one that's smaller is going to give you +2. Or you can think of it as absolute value. Okay, you can think of it of, don't even look at the signs because you already know which one's bigger. What's 4 minus 2? 2. Okay, either way, it doesn't matter. But I do want you to learn how to put the equation in, because let's say the question was x-intercepts, okay? And you didn't know how to find the x-intercept from here. I can quickly see if I have my equation in. If I can zoom out, let me press home. What is my x-intercept? So if I was comparing x-intercepts, oh, there's no x-intercept here. So which one has a bigger x-intercept? This one, because this one doesn't have any. All right, so they're just different questions that you can ask. So you can make a table into an equation so you can see it and compare apples to apples. Both of these are graphs. And that's pretty much it. Let's practice. All right, so I want to take a look at transformations. Question 17 and 18 are transformations. I'm going off the assumption that you've watched the previous video that talks about what all of this means. If you haven't, please go and watch the video that talks about inside and outside. I am going to quickly recap it here, but not teach it in depth. Okay, so looking at question 17, this is the delta math one. So quadratic reflection. All right. All right, so here there will be a discovery for what you have just learned, okay? So if it's inside, it's going to be x and opposite. If it's outside, it's y and whatever you think, and negatives are flips no matter what. So when you get started with this question right here, what happened to the graph? So this is the original graph, y equals x squared. And if you remember when we did parent functions, we looked at what that is equal, also not to mention that we have just been doing a whole bunch of quadratics. So that is y equals x squared. It goes 1 squared is 1, 2 squared is 4, and that's how you get your axis. So what happened to this graph? So I had the solid black line, and then what happened when I got to the black line? Well, you can see this u flipped over, right? It went upside down, and then it moved, looking at the vertex, it moved left 1 and down 4. And those are the notes that you want to write to yourself. So we're going to flip over the x, and then we're going to go left 1 and down 4. And we just need to write the rule. So this is a discovery, so you're just going to mess around with it until you see what it is. Now, I didn't get the same question, so I can't mess around with it here. But if I want to flip it, I'm going to put, remember, negatives are opposite no matter what, right? So if I look at my notes, it says negatives are opposite no matter what. So outside is supposed to be y, inside is supposed to be x. All right, well, this right here is outside my main parentheses. Here's my parentheses. It's outside, so I would think it's supposed to be y, but negatives are opposite no matter what. So this one is going to flip it over the x. So when I make that negative, it automatically flips it. Then I want to do some moves, because now it's going to move from here to here. But in your question, it's moving from here to here. Now, again, this is just me showing you how this is working. All right, so I want to move left 1. So if I want to move left 1, which axis am I talking about? My x, right? Because left and right is x. So if I want to move left 1, it's my x. If I read my notes, it says x is inside your parentheses and it's opposite of what you think. So if I want to move left 1, I go inside my parentheses and it's opposite of what I think. So if I want to go left 1, I would think say -1, right? But instead I'm going to say +1 and see what happens. What do I do? click up, boom, you see, opposite made it move left 1. All right, then I wanted to move down 4. All right, when you're talking about up or down, which axis are you looking at? The y-axis. So what I'm expecting is outside is supposed to be y and whatever you think. So outside, so I'm going to put it outside the parentheses. That means I'm going to put it right here. All right, and it's going to be whatever I think. So if I was standing right here and I said I want to go down 4, what would you do? Add 4 or minus 4? Minus 4. Minus 4 should take it down. So I'm going to come right here and say minus 4. And you should see when you click out that it will move down 4. Okay. Now let me reset this. Is there a way to reset this so I can actually do this question? I don't know if there's a way to reset it. Let's just delete. Let me see. All right, cool. Now I'm going to do this question. So the same thing here. So this one would have been negative outside. Then it should have been f of x plus 1 and then minus 4. That's what the rule would be to get it from this solid to this dotted. So now I'm going to do it with this question. So I'm doing another question, okay? All right, I wanted to flip. So again, flipping it. If it's outside, as here, it's outside, it's going to flip over the x-axis, all right? Because negatives are opposite no matter where they are, okay? Just for a flip, multiplying by negative. So now that it's flipped, I want to go right 2 and up 3 so it can line up. All right, so right 2. Right 2 is which axis? X-axis. So it's supposed to be x is inside and opposite of what you think. So right 2 would mean plus 2, but it's going to be opposite of what I think. So I'm going to say minus 2. Let's see what happens. Yes, that works. All right, then I want it to go up 3. So up 3 is going to be my y-axis, and y is outside. So the number is going to be outside the parentheses, and it's whatever I think. Okay, so I want to put it outside the parentheses, which is right here, and whatever I think is what I'm going to write. So if I was trying to go up 3, I would say, hey, go positive 3 up. Then I would write down positive 3. And you skip out, and boom, it lines up. So knowing the rules will help you do these questions a lot faster. All right, so what you're going to do is now you're going to log into ixl.com, follow these instructions, and I'll give you the last 3 digits for your username. When you get to the work, once you get in, make sure on the top right you see your name. You're going to click Learning, click Algebra 1, and you're going to find DD1, Function Transformation Rules. You're going to do it to 100 4 times. Okay, you're going to see 4 gold medals when you do this. Now, on the 4th time, please do not use your notes. So this is just, do you know the rules? That way you can come and answer this question. What does this transformation do? So if I was answering question 18, what does the transformation do? So let's look at each individual thing. This is a negative sign. It is outside. What does a negative outside do? It flips the graph over the x. So we're going to say, so this negative flip over x axis. All right. What does this plus 3 do right here? This is outside. So outside is going to be y and whatever you think, right? Let me go back to my notes. Outside is y and regular. And because it's a plus or minus, it's a shift on the x or y axis. So I'm going to go up 3. Because it's the y-axis. All right, what does this number do right here? So we actually didn't cover this yet, but this is multiplication. If you look at your notes, it says multiplication is a stretch or shrink in the x or y direction. Now, because this is outside, it should be which direction? Y. So this is going to be vertical. Whatever your answer is going to be vertical because it's outside. If it was inside, it would be horizontal. All right, so it's vertical. And since it's multiplication, it's going to be whatever you think. So it's y and regular. Since it's multiplication, if I take any number, if I have $5 and I multiply it by 2, does my number get bigger or smaller? It gets bigger. And because it's y and regular, it's what you think. So this is a vertical stretch. It gets bigger. Okay, so again, do not worry if this is a little bit confusing to you. That's what this is going to do. If you do it 104 times, you're going to understand the different rules and you should become an expert. Let's practice.